So dear all, welcome to ESE Online, digital platform of ESE Engineering Academy. This is Dr. G. Balaraju, Professor of Mechanical Engineering. On behalf of Mechanical Engineering Department, so we would like to present the solutions for today's exam. So ESE Preliminary Examination and Mechanical Engineering. So first of all, we should know the weightage. So if you see the weightage, in basic thermodynamics, so there were 10 questions. In IC engines, 8 questions. In power plant, 22 questions. In refrigeration and air conditioning, 4 questions. So this is regarding thermal. And coming to heat transfer, 5 questions. FM and turbo machinery, 15 questions. Engineering mechanics, 6 questions. Strength of metals, 11 questions. Theory of machines, 11 questions. Machine design, 11 questions. IM and war, 4 questions. Production technology, 3 questions. Engineering materials, 11 questions. Renewable energy sources, 12 questions. Mechatronics and robotics, 12 questions. And maintenance, so 5 questions. So when you see the total weightage, almost in production side, we have less weightage. And coming to other branch, like specializations like a thermal, in most of the questions are lengthy, and the calculations, definitely calculator is required. And when you select the question in choosy manner, so definitely the student who have chosen a right question, he may be scoring more. And the question paper is moderate to tough, okay, from the students like who wrote the exam. And they expressed that the question paper is lengthy, a few questions are very lengthy. And of course, so then overall, the paper is tough, and we cannot say it is easy. And just we can have the solutions. Just we are going to give the key. So please just stay tuned.
And the open just better, IC engines. Good evening to all of you. My name is B. Veera Kumar. I'm a professor in ESE Engineering Academy. I'll be handling IC engines today for you. So the IC engines paper for IC engines was very lengthy, and it is involving a lot of calculations. But we have to solve this question paper without using a calculator. So here I'll tell you how to solve the questions without a calculator. The first question is, the cubic capacity of a 4-stroke over square spark ignition engine is 245 cc. The over square ratio is 1:1. The clearance volume is 27.2 cc. What is the stroke length of the engine? Okay. Here, volume is equal to 245 cc. 245 cc. L by D ratio is equal to 1.1. L is equal to 1.1 D. 1D. Clearance volume VC is equal to 27.2 cc. Now, volume is equal to VC plus Vs, or this is equal to VC plus pi by 4 D square L, or this is equal to VC is given as 27.2 cc plus pi by 4 D square into 1.1 D, and here it is, this is equal to 245. 245. Now, pi by 4 into 1.1 into D cube is equal to 245 minus 27.2. 245 minus 27.2 is approximately equal to 17.8. 17.8, or D cube is equal to 217.8 into 4 by pi to 1 by 1.1. Okay. Now here you see 4 by pi. This is 217.8 into 4 by 5. 4 by pi is how much? 4 by pi is approximately equal to, this value is 1.272. 1.272 into 217.8. This is equal to, D cube is equal to, roughly this value is 280. 280 by 1.1. 280 by 1.1. Or 280 by 1.1 is how much? It will get cancelled. 260, 25, 255. Now cube root of 255. Cube root of 255, D is equal to I.
Need to write it
Again, huh? Okay, then first we'll please cancel it. First I'll do the calculation. First I'll write down everything, then I'll explain.
Cube root of 255 something was there.
No. Again we have tried everything, no? 245. E is equal to VC plus Vs. That is equal to VC plus pi by 4 D square L. L by D is equal to Yeah, d cube is equal to 255. Cube root of 255. We know that for 243 is cube root of 243 is 7. So this answer should be greater than 7. Therefore, among the answers, there is only one answer which is greater than 7, that is 7.36 centimeters. So the answer is D. So the answer is D. Okay. Now, next question. 77. A 42.5 kilowatt engine has a mechanical efficiency of 85%. If the frictional power is assumed to be constant with load, what is the mechanical efficiency at 60% of load? Cut change. Now here brake power is equal to mechanical efficiency. 0.8. Okay. So in this problem, brake power is given, mechanical efficiency is given. Indicated power is equal to brake power and mechanical efficiency. We get indicated power. We know indicated power and brake power. We get friction power at full load, which is 7.5 kilowatts. He says in the problem that friction power does not change with load. It is constant. So at 60% load also, the friction power will be same, which is 7.5 kilowatts. At 60% load, we'll calculate what is the brake power. And you calculate mechanical efficiency by dividing brake power at 60% load with indicated power at 60% load. That will be giving the answer, which is 77.3%. Hence, the correct answer is D. Next, a single cylinder engine running at 18 RPM develops a torque of 18 Newton meters. The indicated power of the engine is 1.8 kilowatts. What is the loss due to friction power as percentage of brake power? As percentage of brake power. So here N is equal to 800 RPM and it is given Newton meters. So here we use the formula brake power is equal to 2 pi nt by 60,000, and if you calculate approximately you will be getting the brake power as equivalent to 1.57 kilowatts. And what is the indicated power given? 1.8 kilowatts. What is the friction power? 0.23 kilowatts. So here the friction power is 0.23 kilowatts and friction power by brake power is how much? 0.23 by 1.57. 0.23 by 1.57 is how much? Roughly 0.23 by 1.57 is 1 by 8 approximately. Closest answers to 1 by 8. 1 by 8 is how much? $12 point something. The closest answer is here only 9.36%. That only we can give here. Answer is A. Next, 79th question. A gasoline engine working on Otto cycle consumes 8 liters of gasoline per hour and develops 25 kilowatts. The specific gravity of the gasoline is 0.75 and its calorific value is 44,000 kilojoules per kg. What is the indicated thermal efficiency of the engine? Here, the gasoline consumption is given in liters. Specific gravity is given. Specific gravity you can convert to density by multiplying by 1000. 0.75 into 1000 is 750. And if you multiply with the volume, you'll get mass flow rate of gasoline. And the calorific value is given. Indicated thermal efficiency formula is indicated power into 3600 divided by mass of fuel in kgs per hour into calorific value of the fuel. On solving it, you will be getting the answer as 34.1%. Answer is C. Here, next question is question number 80. The bore and stroke of a water-cooled vertical single-cylinder 4-stroke diesel engine are 80 mm and 110 mm respectively. The torque is 23.5 Newton meters. Okay. First, let us calculate what is the brake mean effective pressure of the engine. First, you have to calculate brake power. The brake power is calculated by using the formula pi nt by 30,000. And here you get the answer as approximately equal to 3.69. And then using the formula, brake power is equal to PMB into L into A into capital N into small n by 120. We can calculate the brake mean effective pressure. And substituting the values on calculation, you get the answer as 5.34 bar. And the answer is D. A sequel to this question is 81. The same thing, but in the first problem, the RPM is not given. We have to take it from the second bit because same RPM applies to both problem 1 and problem 2. And here, the rating is changed to 4 kilowatts. Rating is changed to 4 kilowatts. So, he is asking, what is the mean effective pressure at this? Okay. We know that brake power is directly proportional to mean effective pressure. So, BP1 by BP2 is equal to PMB1 by PMB2. Using this formula, we can calculate PMB2. On calculation, you get the PMB2 as 5.78 bar. And the answer is C. Next, question number 83. A 4-cylinder diesel engine, 4-stroke type, has stroke to bore ratio as 1.2 and the cylinder diameter is 12 centimeters. Based on the indicator card, the area of 30 centimeters squared and length of half of stroke is given. The indicated spring constant is given as 20 into 10 cube kilonewtons per meter squared and the engine is running at 2000 RPM. He is asking what's the mean effective pressure. Okay. Now here you see, it's a 4-stroke engine. L by D ratio is 1.2. Cylinder diameter is 12 centimeters. And stroke length is 12 into 1.2, which is 14.4 centimeters. Area of the indicated diagram, AD, is equal to 30 centimeters squared. Length of the indicated diagram is half the stroke. LD is equal to length of the stroke by 2. That is 14.4 by 2, which is 7.2 centimeters. The indicated spring constant is given as 20 into 10 cube kilonewtons per meter squared. But here, there is a mismatch between the units given in the problem and the units given here. So here, if you substitute the values first for calculating mean effective pressure is equal to area of the indicated diagram by length of the indicated diagram into spring constant. If you substitute the values for that, you will be getting the answer as equivalent to 8.33 into 10 to the power of 4. Answer is 8.33 into 10 to the power of 4 newtons per meter squared. Actually, this is given as a wrong answer is given here, practically. And there is a mismatch here also. Please see, here it is given kilonewtons per meter squared, here they are given newtons per meter squared. This also is wrong. Okay. So this mismatch is there here. Kindly note it. Now, the last question, 84, is based on the same data. Same thing, everything. The engine is running at 2000 RPM. What is the indicated power of one cylinder? He is not asking all the cylinders. Okay. So you should take here, the indicated power is equal to PMI into L into A into capital N into small n by 120,000, because the mean effective pressure we got in newtons per meter squared, we have to take by 120,000. 120 we are taking because of 4-stroke engine. On solving it, you will be getting the answer as equivalent to 2.26 kilowatts. But the answer is given as 22.6 kilowatts because he has calculated mean effective pressure wrong in the earlier problem. Please note this correction. For 84, the answer is A. 84, the answer is A.
Right. So as in the afternoon session, we have a mechanical session of engineering services paper. But this year, as we are noticing from previous many years, production related questions in prelims especially are very less weightage, but in mains obviously as every year we are noticing huge number of questions are coming. Whereas this year very few questions were there, that too theoretical, just read the question, observe the data, tick the answer directly, that type of questions were there. Whereas we both together, me and my colleague faculty Ravi sir, will solve those questions one by one. So we'll start going towards the solution of each and every question with a detailed explanation. Ravi sir.
Yes, now see this question, according to the type of stress developed in which one of the following metal forming process is classified under the combined tension and compression type. It's a deep concept, very deep concept. And you can see that the answer is deep drawing. And I'm also here not going to explain in detail, but in the deep drawing you can see that there are total 3 stages are here. You can see the 3 stages. This is 1, this is 2, and this is 3. And in the third stage, we can see there is a combined. You can see that the tension and compression. It is not easy, it is difficult, but I'm not explaining in detail. But in the stage 3, you will get both combined tension and compression type. Hence, you can see here the answer is deep drawing. Now see the next question, in a rolled product in which one of the following is generally 5 millimeter or thicker. Here is, we can give the answer, 5 millimeter or thicker. You can see that what is the thickness of plate. So some people are also saying that greater than or equal to 6 millimeter, or also we can say the thickness of plate is greater than or equal to 5 millimeter also we can say. Not equal to, we can say only greater than. Yes, we can say only greater than 5 millimeter, then it is a plate. But here also what they given, the 5 millimeter or thicker, yes, we can say, no problem. Then it is a plate only. Hence here the correct answer, you can see, this is the plate is the correct answer. The foil, very small thickness, lesser than 1 millimeter. The slab and billet has higher thickness. Now we'll see the next metrology question. Just see the next question.
Right. So in this question, if you notice, what they said is which one of the following consists of those surface irregularities on part which are of the considerable wavelength of a periodic characteristic. See, basically, whenever you look at any workpiece in a microscopic way, by selecting a small region, the geometry of the workpiece may be anything, that workpiece which is produced from any one of the conventional manufacturing methods, by looking that particular zone magnifyingly in a microscopic manner, we are able to notice that for every metal, there are continuous peaks and valleys are present throughout its sampling length, or you can say selected region. Whereas this is what we notice. And combined together along with this, there are large number of impurities if it present in the workpiece volume, that may also appear. So we can say that the continuous marks are lay and the impurities present are flaw, and combined together lay and flaw together over the plane of paper on 2-dimensional length if you represent, we call it as the surface texture. So surface texture is basically a quantitative representation, qualitative representation of any metal surface. So that particular quality level, suppose if you consider with respect to the straight line, that is what we consider as the sampling length of a workpiece surface, we can say ideal surface. So obviously, due to this particular ideal condition, as we are comparing any metal, obvious that every metal volume have a number of impurities also present with that. So based on that particular condition, to calculate magnitudes or to give quantitative representation, we can divide entire surface texture into 2 varieties. One is large wavelength, we call it as the waviness. Another one is small wavelength fluctuations throughout the sampling length, we call it as the roughness. So if you look at this particular basic discussion, I included everything, whereas here among all these options, they are asking considerable wavelength of the periodic characteristic, that is waviness. So with this, production related, very few questions were there, but with this they are completed. So all the very best.
So let's proceed with machine design. Let's see some few other questions which we have got from machine design. So this year we have got almost 11 questions from machine design. So few of which are static data based. One second. Okay, let's see the first question which we have got from machine design here. So this is a question from welds. So here you can see that here he is asking us to choose the minimum size of fillet weld. So which is having a thickness of plate here is considered to be lesser than or equal to ½ inch. See, actually we consider the standard unit as mm, but here he has given the standard unit as inch. Generally, if we follow VB Bhandari, we majorly make use of mm. But here, the examiner has, the paper setter had made use of the textbook Shigley. So if I go through the topic of Shigley from this textbook, yes, we have this table. From this table, you can see that. So within 1/4 to 1/2 inch, so we will be considering the weld size to be. So here you can see that the weld size here is considered as 3/16. So when we are including half as well, we can say that here for this question we can say that 3/16 is the right answer. Why? Because he is asking that if the plate thickness is lesser than or equal to ½ inch. See, most of the students might not have answered this question. Why? Because it is a static data based question. Okay, moving to the next question. So here the fatigue strength reduction factor is given by. See, there are many fatigue strength reduction factors, one among which is fatigue stress concentration factor. So where fatigue stress concentration factor Kf is nothing but equal to, see from standard textbooks you can see the definition to be, it is the ratio of endurance strength of notch-free specimen to endurance strength of notched specimen. It is a standard question which we have got from this topic of fatigue. Okay, if I move to the next question, so this is also a question from fatigue. Here he is asking us to identify what is the equation for Goodman line. So here among these options which we have got, so here he has considered SU as the ultimate strength and Sn dash as endurance strength. So we know that the equation for Goodman theory is sigma m divided by SUT. This is SUT plus sigma A divided by SE is equal to 1 by factor of safety. Where you can see that SUT is ultimate tensile strength and SE is corrected endurance strength. Here in place of SE he has given SE as Sn dash. So from these options you can finally conclude your answer as, see, this is a direct question again. Now one more question which we have got is from Spurgeon. Again, without knowing the equation of contact stress, will not be able to mark the correct answer for this. Again from the standard textbooks, so if I go through the equations of contact stresses, yes, you can see that this contact stress is directly proportional to elastic coefficient Cp, whereas velocity factor and transmitted load, phase width, and then pressure angle, and then these two are related to radius of pinion as well as gear. So here he is asking us to identify contact stress for spur gear is proportional to. Here among these four options, if I go through these two equations, I can mark that the answer is elastic constant Cp. Similarly, let's move to the other question. So a direct question again from bearings. So here the relation between load and life is given, where we know that the relation between load and life, the rating life and load is L is equal to rating life, L is equal to C by P whole power K, where K is a constant for a bearing. So it is dependent on the type of bearing, either that is a ball bearing or roller bearing. See, for a ball bearing the value of K is 3, whereas for a roller bearing the value of K is 10/3. So as we know that the value of K is 10/3 for a roller bearing, here he is asking us to consider roller bearing. See here, he has mentioned roller bearing. For roller bearing the answer is 3.33, which is nothing but 10/3. Moving to the next question, see here, for dynamic loading we need to modify the theoretical stress concentration factor to obtain fatigue stress concentration factor. Yes, we know that the relation between fatigue stress concentration factor and theoretical stress concentration factor is Kf is equal to 1 plus Q into Kt minus 1. See, we are going to correct, see, We call this as KF as actual stress concentration factor, whereas this is KT is considered as the idealistic stress concentration factor. Yes, we are not considering the ideal condition, we are considering actual condition. See here, to identify the value of KF, we require the sensitivity of the material, which is denoted by the parameter Q. So here, we can say that from these options, see here, as we are converting theoretical to fatigue, so what is the primary reason behind it? The primary reason is considering not sensitivity or sensitivity of the material. So here the answer for this question is D. See here you can see that not sensitivity of the material to obtain. See, he has mentioned the same statement twice. Same statement twice. Okay. Now moving to the other question. For a failure of ductile metal under static loading, which of the failure theories is more accurate? See, as we have 5 different theories, among all these 5 theories, so what is accurate theory? He's asking us to consider the most accurate theory. See, one among these materials like mild steel, for a material like mild steel, we have seen that the relation between SYS and SYT, SYS is equal to 0.57 times SYT. For mild steel, 577, this is according to distortion energy theory, and actually for mild steel approximately I can consider that to be 0.57 times SYT. So which means we can say that for this particular question, as we know that distortion energy theory is the right answer. Remember that maximum shear stress theory here is not given. Why? Because even if he has given maximum shear stress here, that is considered to be the most safest theory for ductile materials. Moving to the other question, see here again he has given one question of that type. Yes, in the previous question he has given the most accurate theory, and here the most safest theory is asked. Maximum shear stress theory. According to this theory, the relation between SYS and SYT is. We know that the relation between SYS and SYT is, according to which theory? SYS is equal to 0.55 times SYT. This is according to maximum shear stress theory or Tresca theory. Yes, we have seen all these questions in classroom. Okay, most of the questions, these are all standard questions that we have got. Even this question you can see that consider the following parameters involved in the rating of clutches and brakes. So here he's asking us to consider the rating of clutch as well as brake. Here remember that it is generally power rating is, we know that power equation is what? Power equation, we can write it as T omega, or we can also write it as force into velocity. So here you can see that it is dependent on torque required to accelerate or decelerate the system. Yes, obviously power rating is dependent on torque. Yes, obviously it is proportional to torque. Okay, and it is also proportional to time required to accomplish the speed change. Yes, where omega is considered to be the average speed or mean speed. So we generally consider this to be, yes, this is dependent on the time that is required either to get accelerated or decelerated, which means on these two simple parameters, yes, power rating is dependent on. And here he has given third option as the cycling rate is the number of on and off cycles per unit time. See here, as we are considering mean power, yes, remember that the two parameters which we generally include is torque as well as omega, where here I can say that for this particular question, so it is dependent on 1 and 2. So here I am going with only 1 and 2. So here he has asked one more question. So from brakes, this is on wear rating. So here he has asked the plate type brake, which is considered to be the disc brake. So here the area of friction surface is 20 inches square. See here, actually we measure unit, the unit for area we consider it as mm square, but here unfortunately he has deviated from the standard unit and then he has considered inch square here. The frictional power absorbed about 2 horsepower, the wear rating is. So here we do not have any specific formula for the given data. So from the data that is given, so I can say that, so wear rating is equal to power divided by, see how much power that is lost for the unit contact area. So here we can mark it as 2 divided by 20. From this we'll be getting it as 0.1 horsepower divided by inch square. So here the answer for this question is A. And finally moving to the last and final question from this chapter. So here there is no answer matching to this particular question. See here he has said that in this question a set of 3 bolts were given. Okay, there are 3 bolts which are inducing a clamping force of 4,000 newtons. 3 bolts are necessary inducing this 4000 newtons between two components of a machine. If the allowable stress is 800 Newton per, very, very huge. It's very, very huge. So what is the required tensile stress area of the bolt? So here if I consider what is the load which is acting on each bolt, the total load which is acting, the total clamping load on both the plates is 4000, which means the load acting on each bolt will be 4000 divided by, on each bolt it is nothing but 4000 divided by 3. Now here this applied load which is acting on each bolt has to be lesser than or equal to. So here the permissible stress, allowable stress is given as, so that for bolt the allowable stress is given as 800 megapascal, 800 into core area or tensile area or minimum area of the bolt. So considering this, I can say that 8 ones are 5s are. So which means area or minimum area of this core area of this bolt has to be greater than or equal to 5 by 3 mm square. But can you find 5 by 3 here in these options? I hope so. The person who has set this question has disregarded these 3 bolts. So disregarding those 3 bolts, we can mark the answer as 5 mm square, but we cannot disregard the given data here, as he has said that 3 bolts are used to induce a clamping force of 4000 newtons. Obviously the answer has to be 5 by 3 mm square. So I hope so. So if at all, if in answer key, if he is giving answer as 5 mm square, so which means he is disregarding this 3 bolts. But so here from the calculation that we have got, no option is matching with the data. Okay, with this I conclude with all the solutions of machine design. Now I'll so transfer the podium to Madhushekhar sir, so he'll handle material science. Thank you.
Right. So here I am going to deal with this material science for ESE 2023. Especially from this subject, the questions are moderate to tough. Okay. Some of the questions are very easy. Like we'll see those questions. Like this question is a very simple basic question that is based on the X-ray diffraction, Black's law. That is n lambda is equal to 2d sine theta. Right. Here we should find the d value, that is n lambda by 2 sine theta. In the question, value of n is not given, and so that we are assuming first order of diffraction, and lambda is given 1.54, and 2 into angle is given sine 30. Sine 30 is 1 by 2, so that answer you will get 1.54 angstrom is the answer. So A is the correct answer for this question. Right. Now the second question, which of the following is our main ingredients of Portland cement? It's a straightforward mug-up question. The D is the correct answer. Dicalcium silicate and tricalcium silicates are the main ingredients for Portland cement. And the third question, it's a lever rule based question. The fraction of pro-eutectoid ferrite they are asking, right? The fraction of pro-eutectoid ferrite they are asking from the lever rule question, by drawing the lever line, you'll get the question. So this is the lever line. You can say C naught. This is C naught, that is equal to 1.8% of carbon. This is C alpha, that is equal to 0.025% of carbon. This is C perlite, that is 0.8% of carbon. So mass fraction of pro-eutectoid ferrite alpha, that is equal to C perlite minus C naught by C perlite minus C alpha, that is nothing but 0.8 minus 0.18 by 0.8 minus 0.025. By solving this, approximately we'll get the answer, that is 0.8, right? By solving this, you'll get the answer directly 0.8 approximately. So this is the question. Next question, the oxidation loss on the copper surface is 0.05 mm in 15 hours. How much will be the loss in 225 hours? It's a simple basic question. Actually, the corrosion loss is directly proportional to time. With increasing the exposure time, the corrosion loss increases. So in a simple way, basic, because we are not using calculator, right? 0.05 into 225 by 15. By solving this, approximately you will get the answer, approximate value, that is like by solving this, any one of this option like a D or B, C you will get approximately by solving this. Next, this is another question, the thermal shock resistance. Thermal shock resistance is nothing but like sigma ultimate shear, ultimate strength into and thermal conductivity by modulus of elasticity into coefficient of thermal expansion. By substituting this, that is 650 into 80 by 2 into 10 power 5 into 12 into 10 power minus 6. By solving this, you will get the answer approximately 21.667 into 10 power 3 watts per meter. So B is the answer for this question. Thermal shock resistance formula. If you know this formula, you'll get the answer. Right. Another question, which of the following stainless steel is used in automobile exhaust components valves? Actually, in automobile exhaust components valves and combustion chamber, we are using invar steel. Invar steel, it has a good thermal resistance and also it has a low coefficient of thermal expansion. That's why we are using this one. And the next one, consider the following statements regarding the super alloys. Right? Super alloys are iron nickel based alloys. Here, out of these three statements, this statement is wrong actually. Vital aluminum is not having vanadium actually. So 2 is not correct. So 1 and 3 is the correct answer for this question. So C is the correct one. The plain carbon steel in which the carbon percent is less than 0.8. Less than 0.8 is actually hypoeutectoid steel. More than 0.8 is hypereutectoid steel. So A is the correct answer. And the next question, here it is related to slip and twinning. Right? Slip and twinning if I consider. So all the three statements are right here. By going this slip and twinning, all the three statements are right. So I'll give the answer for this question is D. And the last, another question, which of the following materials are used in turbine blades? Turbine blades are used for inconel, monel and inconel material. Monel and inconel material. These are made up of nickel based superalloys. So nickel based superalloys A is the correct answer. Another question, which of the following steels are used for propeller hubs, welded steel propeller blades, engine bolts, etc., etc. Here also we are using superalloys here, nickel based nickel and chrome based alloys we are using. So B is the correct answer for this question. So these are the questions. Most of these questions are like mug-upping questions, theoretical type questions. Next our colleague Devanand sir will take heat transfer subject.
एक मिनट चलो. Hello everyone, now come to the heat transfer. So the statement 1, fluid motion is produced due to the change in the density resulting from the temperature gradient is called free convection. This is absolutely correct. And the statement 2, the movement of the fluid in the free convection is due to fact that fluid particle in the immediate vicinity of the hot object become warmer than the surrounding fluid resulting in a change in density. That is absolutely correct. Free convection is due to density difference and density due to the change in temperature. So both the statement 1 and 2 are individually true and statement 2 is a correct explanation of A. So this should be the right answer. Next. The inner surface of plane wall is at 40 degree and the outer surface is at 20 degree. The wall is 250 mm thick and the thermal conductivity 0.52. So this is the plane wall and this side temperature T1, this side temperature T2, this is L and this is K. We need to find what is the rate of heat transfer per unit area. This is so repetitive question almost every year. The formula is this is T1 minus T2 by L. Just substitute, you will get heat transfer per unit area. If you solve this, you will get answer 41.6. Round off, easily you will get it. Next, direction for the following two questions. Read the following information. Hot water at 98 degree flow through a 2-inch schedule 40 horizontal steam pipe. Inner diameter 0.0525, outside diameter given, K of the pipe given, and it is exposed to atmospheric air at 20. The water velocity given in centimeter per second, we need meter per second. The properties of the water. The first question is Reynolds number. So what is the Reynolds number formula? And everyone know this is di by mu. So in this question we need a calculation because it's very lengthy calculation. If you substitute all this, make sure velocity should be in meter per second. If you do that, you will get this answer 44680. It's just a calculation part. And in the next one, in the same question, the next bit is what is the convective heat transfer coefficient? So remember, convective heat transfer coefficient Nusselt number HI di by K. Okay, at the inlet. But the problem is heat transfer coefficient having the same unit, watt per meter square Kelvin or watt per meter square degree Celsius. So I don't know why the examiner given both same value, but remember 1961 watt per meter square degree Celsius or 1961 watt per meter square Kelvin. Both are absolutely same. So strictly speaking, A and B should be the answer. So A and B should be the answer. So suppose if you don't have any option, if you want to pick anything, so you need to go for degree Celsius maybe because given in degree Celsius, but from my side A and B both is the right answer because heat transfer coefficient value is same in watt per meter square Kelvin or watt per meter square degree Celsius. But if you want to pick in the exam, if you are panic, then go for A. But answer is A and B. Next, next, water is at the rate of 68 kg per minute is heated from 35 to 75. Okay, so TC1 is 35, TC2 is 75, having specific heat given. But this is oil specific heat. The fluids are used in a counterflow double pipe heat exchanger and the oil 110 and leaves at 75. The overall heat transfer coefficient is 320. What is the total rate of heat transfer? The question looks like we need to find LMTD and all that, but it is not required. Simply this information of the code m dot c cc tc2 minus tc1. If you calculate this, just calculate this, you will get 189.5 kilowatt. So that should be the answer. So this is the simple one. So this is from my subject. Now my colleague will take care.
subject theory of machines and vibrations. So this year guys, the trend was like they have given the common data questions, and one more point to observe here is that there is no question asked from the mechanisms chapter, which is a very big chapter in this subject, okay, and that is having almost, or that will be contributing for 30% of this subject. So let us start the discussion. Here read the following information and answer the 3 items follow. Yeah, this is a common data question guys, and this is a spring control governor given. Basically here the question is from the controlling force for spring controlled governor. So here for spring control governor guys, we can write the expression for controlling force F of R, that is equal to AR minus B guys. So here the radius is given, that is at the radius of 450 mm, at the radius of 450 mm, that is R1 is equal to 450. The controlling force F1 is equal to, that is 1450, that is 1450 newtons, and at another radius R2 is equal to, that is 250 mm, and F2 will be,
Thank you.
this controlling force is 750 newtons. Now guys, here we have for the different value of controlling forces and solve for A and B guys. So if we are solving for A and B, like here the first equation would be 1450 is equal to, here the radius guys, it should be divided by 2. Okay, radius should be divided by 2. I missed writing here. So this should be divided. A times of 0.225 in meters we have to write. The value of R should be in meters minus B. This will be one equation. And the second equation will be for 750 is equal to A times of 0.125 minus B guys. So if we solve for this, we'll be getting the value of A as 7000 and the value of B will be equal to 125. I repeat, minus 125. So by this we can conclude the governor is stable governor. Okay. By this we can conclude this is a stable governor. So here we'll be getting B value as, okay. First initially we have to take this as plus sign, and then after that we'll be getting B as one negative value. So now what is being asked? What is the speed at which the governor runs when the balls are at 300 mm? Now guys, the radius of rotation is given as 150 mm, or that is 0.15. So now we need to substitute this radius in the controlling force F of R. That is F is equal to 7000 into 0.15 minus 125 is equal to mr omega square, is equal to mr omega square. So m is given as 8 kgs and r will be 0.15 and omega we are required to calculate. So upon calculating this omega, we'll be getting an answer very close to 29 radians per second, and if we convert this into RPM, we'll be getting option C as the answer guys. Option C as the answer. Option C as the answer. Okay. Next one, the 17th question. What is the isochronous speed? Okay, so again the same data is given guys. So for this we are required to calculate the isochronous speed. So for isochronous, the controlling force will be equal to, for isochronous, the controlling force F of R will be equal to A times of R. A we have calculated that as 7000. 7000 times of R is equal to mr omega square. So here R and R will be cancelled and m is 8 kg. Okay, raised to the power of 0.5 is equal to omega. And then if we convert this into RPM, we'll be getting this as n is equal to 282.47 RPM guys. Okay, so option A is the answer, guys. Option A is the answer. Okay, and the next question is what is the initial tension? What is the initial tension to be increased to make the governor as isochronous? Guys, we are getting the equation of controlling force as that is F of R is equal to that is 7000 R minus 125. So we have to make it isochronous, it should be 7000 times of R. Okay, 7000 times of R. So which means that initial tension has to be increased by 125 units or 125 units. So if we are increasing the initial tension further, then the governor may become unstable also. Okay, so here to make it isochronous, we have to increase the controlling force by 125 units. Option B will be the answer, guys. Okay, next question. Yeah, this is a direct question from the gyroscopic torque. So the mass of the turbine rotor, the mass is given, that is M is equal to 8000 kgs, and next is radius of gyration is given as 0.75 meters. Okay, it rotates in clockwise sense. It rotates with 1800 rpm. N is equal to 1800 rpm in clockwise sense when viewed from the stern. Okay. So what is the gyroscopic couple if the ship is traveling at a speed of 100 kmph and it is turning left with a radius of 80 meters, guys? Okay, so he's not asking you the effect. Directly we have to substitute these values in the formula, that is C is equal to I times of omega into omega P. So here this speed should be converted into radians per second. We can write this as m times of k square into 2 pi n by 60 into omega P will be equal to V by R. V we have to convert in meters per second and R is already given in meters. So we have to substitute all these values, guys. Upon substituting, we'll be getting the answer as option D, guys. Option D will be the answer. Okay, this is one of the question from the gyroscope. Okay, and again the same question is being continued, guys, and they are asking the effect of gyroscope while the ship is steering, and the second case they are asking the effect of gyroscope while the ship is pitching, guys, while it is pitching. So here the data relating to I and omega will remain constant. Only the direction of velocity of precision will be changed. Velocity of precision will be shifted about different axis, guys. Okay, so here, yeah, so here what is the gyroscopic couple if the ship is pitching and the bow is descending with maximum velocity? Take the pitching with the simple harmonic motion. Yes, the pitching is executed in the SHM form and the periodic time is 20 seconds and the total angular moment between the extreme position is 10 degrees, guys. So here the angular velocity for completing one cycle will be equal to 2 pi by time period. That is equal to 2 pi divided by this will be 10. And guys, here we are going to take the pitching for half of the angle. Okay, because about the mean position the ship will be either ascending or it will be descending, guys. So here the velocity of precision becomes 2 pi by 20 into 5 degrees into pi by 180, guys, into pi by 180. Okay, so this will be the velocity of precision, and upon doing the calculation we'll be getting omega P as 0.027 radians per second, guys. Radians per second. And now, guys, we have to substitute this in the gyroscopic torque formula, that is C is equal to I omega P. So I will remain, that is 8000 times of 0.45 square into omega will be 2 pi into 1800 by 60 into the velocity of precision. which is equal to 0.027 radians per second. So upon doing this calculation, guys, we'll be getting the answer as somewhere around 23 or 24,000. So which is very much close to the option A. So for this question, option A will be the answer. Okay, moving to the next question. Yeah, a petrol engine 100 mm is in the diameter. Okay, this is the size of the bore and stroke of 120 mm. So size of the bore, that is capital D, is equal to 100 mm, and stroke, which is given by 2 times of R. R is the crank length, so that is equal to 120 mm, and has a connecting rod of length 250 mm long. So length of the connecting rod, which is equal to 250 mm long, and mass equal to 1 kg. Speed in RPM is 1800. So the gas pressure is 0.5 megapascal at 30-degree crank angle, and from the top dead center. Okay, during the explosion stroke. What is the force on the piston due to the gas pressure? Guys, all the data which is given, that is only bore diameter we require, and stroke length is not needed, connecting rod length is not needed, mass of the piston is not needed, speed and crank angle is not needed. All these guys, all the data is the redundant one, guys. So here pressure and the bore diameter is important for us to calculate the gas force or the piston effort. Piston effort is equal to, that is equal to gas force. We are not required to consider the effect of inertia force. So this will be equal to P into pi by 4 times of D square, guys. So this will be 0.5 into pi by 4 into diameter is 100, guys. So upon calculating, this will be 3927 newtons, guys. Option C will be the answer, guys. Option C will be the answer. Okay, moving to the next question. The reduction of speed from 360 RPM to 120 RPM is desired by the use of chain drive. So the driving sprocket has 18 teeth. What is the minimum number of, what is the number of teeth on the driven sprocket? Guys, here we know that is speed is proportional to, or inversely proportional to, speed is inversely proportional to number of teeth, guys. Okay, so N is inversely proportional to number of teeth. Okay, so here I can write it as N1 T1 is equal to N2 T2. So the speed is 360 RPM, that is of the driven, that is for the driven. Larger speed will be for the driving member. So the driving here, the driver has 18 teeth and the driven has a speed of 120 RPM, and T2 we are required to calculate. So guys, when we are reducing the speed by 3 times, okay, when we are reducing the speed by 3 times, the teeth will be increased by 3 times. Directly we can jump to the answer, that is option C will be the answer, guys. Option C will be the answer. So T2 will be equal to 54, that is 18 3s 54. Next one, which one of the following types of cam has either convex or concave surface? Guys, here globaloid cam will be either, it will be manufactured by using the convex surface or concave surface. So option C is the answer, guys. Option C is the answer. Okay, next question. A spring mass system consists of spring of stiffness 350. Stiffness is given as 350 Newton per meter. Okay, mass of 0.35 kgs. The mass is displaced 20 mm beyond the equilibrium position. Some initial displacement has been provided and released. The damping coefficient is C is equal to 14 Newton second per meter. This is given. What is the undamped natural frequency? Guys, these data relating to displacement, data relating to damping is not at all required. They are simply asking the natural frequency omega n is equal to root over k by m. So k is given as 350 divided by 0.35. So this will be equal to root 1000, guys. Okay, this will be equal to root 1000. Root 1000 means approximately this will be 31. So option B is the answer, guys. Option B is the answer. Okay. So yeah, they are asking in radians per second only, right? Next one is, which one of the following methods or principle make use of the fact that is maximum kinetic energy is equal to maximum potential energy in the free vibration? Guys, in the Rayleigh method, we'll be using the condition PE max is equal to KE max. In the Rayleigh method, we'll be using this. Okay, so option B is the answer, guys. Right? Next one, the distance between the two parallel shafts connected by the Oldham coupling is 25 mm. The driving shaft revolves at 240 rpm. What is the maximum velocity of sliding? Guys, this is a straightforward question. V into the distance, the eccentricities between the two shafts, that is E times of omega. So E is given as 25 into 10 power minus 3 into 2 pi into 240 divided by 60, guys. So upon solving this, we'll be getting the answer as 0.628 meters per second, guys. 0.628 meters per second will be getting the answer. Option A is the answer, guys. So that's all from the theory of machine, guys. I'll be inviting my colleague to take over this discussion forward.
Let us take the question from the subject of fluid mechanics. The first question over here is, a spherical water drop of 1 mm diameter splits up in air into 64 smaller droplets of equal size. The surface tension coefficient is equal to sigma is equal to 0.073 meter. What is the work required in splitting up the drop? The work required over here is equal to change in surface energy. Change in surface energy is equal to sigma multiplied to change in surface area. That is equal to sigma into surface area final minus surface area initial. Now if you are converting into 64 droplets, it is going to become 4 times that particular area, surface area. So this will become equal to sigma multiplied to 4 pi d square, because a sphere's surface area is given by pi d square. So surface area final is 4 pi d square minus initial surface area is pi d square. This will be equal to 3 pi sigma d square. Now, how do we choose the options? Diameter is 10 power minus 3. So this itself will give me 10 power minus 6. Now what is this particular value equal to? 3 pi sigma. You see 3 pi is very close to 10. Slightly less than 10 but still very close to 10. So if I take this as 10 and if I take this as 0.073, this value will be approximately equal to 0.73 into 10 power minus 6. But our actual answer is supposed to be slightly less than 0.73. Therefore, the correct answer over here will be option C, that is 0.69. Okay? Moving further. The question over here is saying, what is the intensity of pressure in ocean at a depth of 1,500 meter, assuming salt water is incompressible with a specific weight of 10050 Newton per meter cube? This is a direct question, gamma times H. But I have to look at the options first of all to decide whether to take some assumptions or not. You see over here, the answers are given in megapascal and the spacing is quite good. You're having a decent amount of spacing between the options. So what I'll do is, instead of taking 10050, I'll take 10000. So if I write gamma times H as the pressure, it is 10 power 4 multiplied to H is equal to 1500. 1500. These many pascal is the answer. In megapascal, this will be equal to 15 megapascal. Now look at the answer, which is very close to 15 megapascal, that is option A. You don't have to get the exact number, remember this thing, you just have to get the answer. Answer and number are two different things. Next thing, the question is saying over here, oil of specific gravity 0.8 acts on a vertical triangular area whose apex is in the oil surface. The triangle is isosceles 3 meter high and 4 meter wide. A vertical rectangle area 2 meter high is attached to the 4 meter base of the triangle and is acted upon by water. What is the magnitude of resultant hydrostatic force on the entire area? Consider acceleration due to gravity as 9.81. Look at the options again. The spacing is quite decent enough. He'll keep saying, take G is 9.81. You keep neglecting it and take G is equal to 10 meter per second square. You have to get the answer. Now you see, you're having a triangle, and to the triangle you're having a rectangle connected over here. The upper area is that of oil. So if I say gamma into area into H bar for oil, that will be equal to, gamma over here is equal to 8. Area is equal to, height is 3 meter, base is 4 meter. So half base height will give me how much? Half into 4 into 3 will be equal to 6. H bar is equal to, for a triangle you have to go 2/3 depth down to get the value of H bar. So 2/3 of 3 is equal to 2. So for the triangle you are having 6 times 8 is equal to 48 times 2 is equal to 96. I'm getting 96 kilonewton for the triangle area. Now for the rectangle, what I'll do is I'll go for pressure prism approach. If I go for pressure prism approach, what do I have over here? I'm having over here a pressure of 3 times, because the height is 3 now. 3 times 8, that is equal to 24. And I'm having water, therefore 10 times 2, because the height is equal to 2. Therefore this is equal to how much? It is equal to 44. It is equal to 44. So I'm having a trapezium of base 24 on top, 44 on bottom. The average of these two bases is equal to 34. 34 times area is equal to, area over there is 8. 34 times 8. So 96 plus 34 times 8. If you calculate 34 times 8, it is 256 plus 16, 272, let us say. 272 plus 96 will be equal to, 368, let us say. 368 will be the value. Now, I have taken assumption G is equal to 10 instead of 9.81. So actual answer should be less than 368. The correct answer therefore is option B, 361. You see the deviation is very small, whatever we are getting from. Next question. The question says air flows through a duct with a pitot tube measuring the velocity attached to a differential manometer containing water. The deflection in the manometer is 100 mm. Assuming the density of air is constant and equals to 1.22 kg per meter cube, the coefficient of tube is 0.98. What is the air velocity? Again, he is saying take the value of G as 9.81. He'll keep saying, we'll keep neglecting. So the value of velocity over here is equal to coefficient of velocity into root over of 2G times HM multiplied to SM by SW minus 1. Now you see there are many places where you will get trapped in calculations. I'll neglect all those places. I'll take the value of CV as 1, 2G as equal to G as 10, HM is HM fine. SM by SW minus 1, you see you're having a very high value of SM by SW compared to 1, you can neglect that 1 over there. If you do this thing, you will get root over of 2 times 10 times HM is equal to 0.1 meter times density of water by density of working fluid. Density of water is 1000. Density of working fluid is equal to 1.22, he is saying, 1.22. Now you see 10 and 0.1 cancelled off. This will come out to be 2 times nearly 800. 2 times 800 is equal to how much? 1600. Under root of 1600 is equal to how much? 40. Our answer is 40. Now look at the options. Options, the closest option to 40 is what? 39.3. The answer is option C, 39.3. Moving further. The next question. Water flows in a circular pipe at one section. The diameter is 0.3 meter. Static pressure is 260 kilopascal. 260 kilopascal. Velocity is equal to 3 meter per second. Elevation, the value of Z is equal to 10 meter above the ground level. The elevation at the second section downstream is 0 meter and the diameter is equal to 0.15 meter. Frictional effects may be neglected. Assume the density of water is 999 kg per meter cube. Now this is a trouble for you. If you are getting trapped in 999, God bless you then. You can take it as 1000 straight away. What is the gauge pressure at the downstream section is asking. Again the value of G is 9.81, neglect it. Now at the second section he wants the value of pressure. The value of velocity is equal to how much? If the diameter is half, the area is 1/4, the velocity is 4 times. So this velocity will now become 12 meter per second. The datum later on is equal to 0. I'll take the value of G as 10. Now if I apply Bernoulli equation without losses, I'm going to get P1 by gamma, that is 6T by gamma is 10 plus V1 square by 2G, 3 square by 2G, 3 square is 9, divided by 2G is 0.45 plus Z1 is equal to 10, must be equal to P2 by gamma, we do not know the value of P2, P2 by 10 plus V2 square 2G, V2 square is equal to 12 square 144 divided by 20 is equal to 7.2 plus 0. This is what I am having. अब देखिए 26 plus 10 36, 36.45 minus 7.2. 36.45 minus 7.2 whole multiplied to 10 will be the answer. 36.45 minus 7.2 will be equal to 29.25. 29.25 into 10 will be equal to 292.5. My answer is 292.5. I just have to check the answer closer to 292.5. Option B is correct over here, 290.57. Next question. Water 20 degrees centigrade is flowing between two-dimensional channel in which the top and bottom walls are 1.5 mm apart. If the average velocity is equal to 2 meter per second, what is the maximum velocity equal to? This is a direct question. You should know that in the case of laminar flow between two fixed parallel plates, the maximum velocity is equal to 3 by 2. Umax is equal to 3 by 2 times average velocity. Go by that formula. Answer is option D over here. Next question. Air moves over a 10 meter long flat plate. The transition of laminar to turbulent flow takes place between Reynolds number 2.5 into 10 power 6 and 3.6 into 10 power 6. The free stream velocity is 30 meter per second. Kinematic viscosity hai ye. This is kinematic viscosity. It's not V, it's nu. Nu is 1.5 into 10 power minus 5 meters square per second. Maximum distance from the leading edge of the plate along which one expects laminar flow in the boundary layer. So basically he's asking you critical position. The value for critical position is equal to, you can take laminar boundary layers, critical Reynolds number is 2.5 into 10 power 6 is equal to velocity into x critical divided by nu basically. V into x by nu, right? So the value of x critical will be equal to how much? X critical will be equal to 2.5 into 10 power 6. Nu is equal to 1.5 into 10 power minus 5 divided by velocity is equal to what is the velocity is given? 30 meter per second. Velocity is 30 meter per second. Now you see 10 power 6, 10 power minus 5, excuse me, 10 power minus 5 and 3, 0 are gone. Now this is 2 times, this is 1 time, 2.5 by 2 is equal to 1.25. The value is 1.25. Answer B will be a relatively good answer. Going further. Now this is a question where basically the question itself is wrong. Okay. So if you can challenge, you may challenge it, you may get the marks. Because first of all, this data is wrong. Kinematic viscosity for air is not 1.5 into 10 power 5 meter square per second. It is 1.5 into 10 power minus 5 meter square per second. Let us say you still get this particular value. He should tell you what is the value of, for this particular question, he should tell you the value of the constant we find out for boundary layer thickness. Now, I know the value, so I'm solving it accordingly. I'm assuming that the profile is parabolic in nature. For parabolic wave profile, the value of that constant is equal to 5.48. Keep this in mind. Let us start the question. The question is saying air is flowing with kinematic viscosity so and so and density so and so over a flat plate. The free stream speed is 15 meter per second and the distance is 1 meter from the leading edge. X divided by nu, velocity is equal to 15, x is 1 divided by nu, this is minus 5 basically, 1.5 and 10 power minus 5, this will become equal to how much? This will become equal to 10 power 6 basically. So root over of 10 power 6 will be equal to 10 power 3. So 5.48 divided by 10 power 3 meter is equal to how much? 5.48 mm. Now, I got this particular answer after making many assumptions which might not be possible for you in examination. So you may very well challenge this particular question. Now, based on this data, only one more question was there for which the again answer is not, we can't get the answer very easily unless he gives us some more data. Over here he's saying, what is the wall shear stress for completely laminar flow? I am assuming the value of CF, coefficient of friction over here, is equal to 0.664 by root over of RE. And I'm saying the value of wall shear stress is equal to CF multiplied to half rho V square. I will not waste your time. For this particular value, I'm getting the answer as 0.09. 0.09 I'm getting the answer. The closest value is coming out to be 0.1. So I'll take A as answer. Still, this question requires some more data. Okay. Moving further to the next question. The question is saying a hollow cylinder of 0.6 meter diameter open at top consists of some liquid and spins about its vertical axis, producing a forced vortex motion. Okay. What is the height of the vessel so that the liquid just reaches the top of the vessel and begins to uncover the base? 100 mm. If a fluid is forming a parabola and uncovering the base, that time I can straight away apply a relationship over here between R and H as H is equal to R square omega square divided by 2G. The value of R over here is equal to how much? The value of R is equal to 0.3, R equal to 0.3 square. Omega square is equal to, now he has given you in RPM, so you can go for pi dn by 60, pi dn by 60 whole square, pi dn by 60 whole square. And one more thing, pi square is nearly equal to 10, you can use that logic over there. Divide by 2G, again take the value of G as 10. If you do this calculation, it will come out to be approximately 0.5 meter. It is looking lengthy, but if you take that assumption of pi square is approximately equal to 10, it will reduce your effort. Okay? So the answer over here comes out to be approximately 0.5 meter. Answer is D over here. Next question. The velocity of air at an outer edge of a tornado where pressure is 750 mm of Hg and diameter is 30 meters is 12 meter per second. Considering the density of air to be constant equal to 1.2 kg per meter cube, specific gravity of mercury 13.6, what is the velocity of air at the radius of 2 meter from its axis? Now all this data of pressure and all those things are not required. They're irrelevant over here. Let us model this particular tornado with free vortex motion. If you go for free vortex motion, V1 upon V2 will be equal to R2 upon R1. I hope you remember that velocity is inversely proportional to R. So you can say the value of V1 is equal to how much? 12 meter per second divided by V2 is equal to R2 over here is equal to how much? R2 is equal to 2 meter divided by R1 is equal to how much? 30. So from here we get the value of V2 is equal to, if you check this thing, you will get the value of V2 R1 is equal to how much? The value of R1 is 15, sorry, not 30, diameter is 30. So you'll get the value of V2 is equal to 90 meter per second. The answer is option, excuse me, I'm sorry. Our answer is option D over here. Next question. Now we are going to hydraulic machinery. The question over here is regarding a Pelton turbine.
The question says a Pelton turbine is driven by two jets generating 4 megawatt at 375 revolution per minute, RPM basically. The effective head at the nozzle is 200 meter of water and the nozzle velocity coefficient is 0.98. The axis of the jet are tangent to the circle, 1.5 meter in diameter. The relative velocity of the flow across the bucket is decreased by 15%. So basically he has given you some loss coefficient over here, 15%, and the water is deflected through an angle of 150 degrees, neglecting the bearing and windage losses. What is the jet speed ratio? Now jet speed ratio, let us say, is given by, or you can use phi also for this thing. It is given by U divided by root over of 2gh. That is equal to pi dn by 60 divided by root over of 2gh. Now again I'm making an assumption that pi and root g are approximately same. If I cancel off pi and root g over here, I get this thing as d into n divided by 60 into root over of 2h. So d is equal to how much? Diameter is equal to 1.5 meter, he is saying 1.5. N is equal to how much? 375 divided by 60 into h is equal to the value of h over here is equal to, the height is given to you as, 1 second, 200 meter of water. So h is equal to 200 meter of water. So root over of 2 times 200 is equal to 20. If you calculate this value will come out to be approximately equal to 50% or less than 50%. So let us say slightly less than 50%. So the correct answer over here will be option B. Next question. For the very same data, the runner efficiency of the Pelton turbine is equal to how much? Now efficiency formula is equal to how much? 2u into v minus u multiplied to 1 plus k cos beta whole divided by v square. Over here u is equal to pi dn by 60. This will take some time to calculate, and the value of v is equal to the coefficient over here, that is 0.98 into root over gh, and the value of k is equal to 0.85 because 15% is loss, 0.85 is remaining. The value of beta is equal to 30 degrees because it is deflecting by 150 degrees, so beta is equal to 30 degrees. You put in all these particular values, you will get the answer as option C. This will take some time. Answer is 86.6%. So these are the questions for the subject of fluid mechanics and hydraulic machinery. Thank you and all the best.
Good evening, friends. Now let us look at thermodynamics. And this year it is moderate to tough. I can't say it is easy, it is moderate almost. This is the first question. Which of the following is Gibbs phase rule? And where P is the number of phases, F is the degrees of freedom, C is the number of components, and N is the, he said N is the number of non-compositional variables. What is actually Gibbs phase rule? Gibbs phase rule is P plus F is equal to C plus 2. This is actually Gibbs phase rule. But actually he has given, these are the options, A, B, C, D, these are the options. Let us take option A. This option A I am taking, P plus F is equal to C plus N. If you compare actually these two equations, P plus F, and this side C plus 2, and this is C plus N. So if you compare straight away for this question, answer is option A, because in place of 2 has given N, and N he said N is the number of non-compositional variables. That is correct only. N is non-compositional variables, that is correct only. So straight away for this question, answer is option A. Right, it is a straight question. For this question, answer is option A. Let's go to the next question. It is a statement 1, statement 2 question. Statement 1, he said, heat is defined as the form of energy that is transferred between the system and surroundings due to the temperature difference. Yes, absolutely, the statement 1 is correct. It is a straight question. Absolutely, statement 1 is correct, because we know that heat transfer takes place due to temperature difference, right? Statement 2, it is given that the temperature difference is the driving force or potential for heat transfer. It is also absolutely correct. Because of the temperature difference, heat transfer takes place. That is also correct. So individually, statement 1, statement 2 correct, and statement 2 supports statement 1 because of the temperature difference. He said in statement 1, he said due to the temperature difference, and here also he is mentioning that the reason because of the temperature difference. Because of the temperature difference, this is the driving force. So statement 1 correct, 2 is correct, and statement 2 is supporting statement 1. Therefore, for this question, answer is option A. Answer A is the option. It is a straight and simple question. Let us go to the next problem. It is also statement 1, statement 2, and the simple air standard cycle. Simple air standard cycle. In air standard cycle, the name itself, it is there. Air standard cycle means air is working fluid. Simple air standard cycle, air is working fluid analysis can't provide the variation of thermal efficiency. He said can't predict the variation of thermal efficiency with the mixture strength since air is assumed to be working fluid. Yes, absolutely correct. Since air is working fluid, it can't predict. He said it cannot predict the variation of thermal efficiency. Yes, it will not predict the variation of thermal efficiency because air is working fluid. Statement 1, absolutely it is correct. Because in air standard cycle, air is working fluid. So here we will not take any mixer strength. So straight away statement 1 is correct. Statement 2 says that fuel air cycle analysis. He said the fuel air cycle means fuel plus air cycle. Fuel air cycle means fuel plus air analysis suggests that if thermal efficiency will deteriorate, thermal efficiency, he said, deteriorates. Thermal efficiency will deteriorate. That means the thermal efficiency decreases. Thermal efficiency will deteriorate means thermal efficiency decreases as the mixture supplied to engine is enriched. Mixture supplied to the engine is enriched. Enriched means the fuel composition increases. If the fuel particles are increasing, basically it is a fuel air cycle. In fuel air cycle, there is air and also there is fuel. But actually in air standard cycle, only air is working fluid. Only air is working fluid. So by taking only air, thermal efficiency of air standard cycle is higher. Thermal efficiency of air standard cycle will be higher than that of the fuel air cycle because of fuel particles. In fuel air cycle, we will be taking fuel particles also. By taking fuel particles, so here actual things will come into picture. Combustion will be there. Specific heats will vary because of these losses, specific heat variation and combustion reactions. Because of these losses, thermal efficiency is going to decrease. Yes, in fuel air cycle, because when mixture supplied is enriched, the thermal efficiency decreases. Statement 1 is absolutely correct. Statement 2 is also absolutely correct. Individually, they are correct. 2 is not supporting 1. So therefore, for this problem, answer is option B. Individually correct, and therefore answer is option B for this problem. Let us go to the next problem. It is a Rankine cycle. He said Rankine cycle works between the pressures are given. Boiler pressure is 3 megapascal and condenser pressure is 4 kilopascal. Condenser pressure is given 4 kilopascal. So straight away data is given. It is a straight question. It is a straight and simple question. So he said the enthalpy of steam from the steam tables at 3 megapascal 30 bar, the saturated vapor condition, and yeah, the enthalpy of steam entering the turbine, directly given. Enthalpy of steam entering the turbine means state 1. At state 1, enthalpy is 2802.3 kilojoules per kg. This is inlet to the turbine, enthalpy inlet to the turbine. And enthalpy of steam leaving the turbine, enthalpy of the steam leaving the turbine, that is H2. H2 is 1862.04 kilojoules per kg. Inlet to turbine enthalpy is given and exit of turbine enthalpy is given. And consider the pump work. Pump work is given as 3 kilojoules per kg. All are in kilojoules per kgs. So this is a question number 1 because it is the common data. First question, what is the work ratio? Work ratio is defined as W net by W expansion. Work ratio is defined as W net by W expansion. W net is W turbine minus W pump by W expansion is nothing but W turbine, which can be written as 1 minus W pump by W turbine. This is 1 minus W pump by W turbine. Pump work is directly given and turbine work we need to calculate. And turbine work can be calculated. W turbine is equal to H1 minus H2. H1 is already given and H2 is already given. So H1 minus H2. H1 2800, 2802. 2802.3 minus 1862.04. This is roughly, otherwise directly pump work by W, which is equal to 1 minus, pump work is directly given, pump work is 3. Pump work is directly given, that is 3. And W turbine, if you calculate, roughly this is going to be 940. And this ratio is almost 0.003. This ratio, 1 minus, this ratio is almost 0.003. So therefore, this is almost equal to 0.99. This 1 minus something which is almost equal to 0.99. So from the options, 0.99. From the options, answer is option D. For this problem, answer is option D, work ratio. Let us go to the next problem. Same data, next question. What is the specific steam consumption? The specific steam consumption is defined as specific steam consumption SSC is equal to 3600 by W net. It is a straight question. 3600 by W net, which is W turbine minus W pump. W turbine minus W pump. So these values already we have. Turbine work, here we have some value, and which is W turbine, this we can calculate, W turbine we can calculate, and W pump is already given. So which is almost, this is 937.26, which is almost, this is 3.6, 3600 by this value, almost it is approximately 3.6. Approximately it is 3.6. From the options, answer is option B. Specific steam consumption for this problem, answer is option B. Let us go to the next problem. A certain perfect gas is given, mass is 0.01 kilograms, occupies volume is given 0.003 meter cube, pressure is 7 bar is given, 7 bar is, that is 7000 kilopascal, 7 into 100, 700 kilopascal, 700 kilopascal, allowed to expand until the pressure is, initial pressure is 700, after expansion pressure is 1 bar, that is 100 kilopascal. The final volume, initial volume is given and final volume which is 0.02 meter cube. What is the molar mass? molar mass or molecular weight, both are same. Molar mass or molecular weight we need to find kg per kilomole. Universal gas constant is given, that is 8314.5 or 8.314 kilojoule per kilomole Kelvin. And it is also a straight question. For ideal gas we can write PV is equal to MRT, and by taking initial conditions, P1 V1 is equal to MRT1. From this equation we can calculate R. R is equal to P1 V1 by MT1, all are given. P1 is given, that is 700, and V1 is given 0.003, and mass is 0.001. Mass is 0.01 into temperature. Initial temperature 131 is given, 131 plus 273. So by calculating this one, R we will be getting roughly, R is roughly it is 0.5, roughly 0.5 kilojoules per kg Kelvin. This is R value, and the relation between R and R bar, R is equal to R bar by M, where R bar is universal gas constant, M is molecular weight. R we have roughly 0.5, R bar is 8.314 kilojoules per kilomole Kelvin and molecular weight. So by using this relation, it is approximately 16. M we are getting from this equation, molecular weight we are getting approximately 16 we are getting molecular weight. So from these options A, B, C, D, answer is option D, 16 kg per kilomole. This is the molecular weight. For this answer option, for this problem, answer is option D. Let us go to the next problem. What is the highest possible thermal efficiency of the heat engine? Heat engine is given. For heat engine, maximum possible thermal efficiency is Carnot efficiency. Maximum possible thermal efficiency for heat engine is Carnot cycle. Carnot cycle or maximum efficiency for heat engine 1 minus T2 by T1 or 1 minus TL by TH. Temperatures are directly given. Higher temperature is given and lower temperature is given. Temperatures must be in Kelvin. 2000 plus 273 and 10 plus 273. 1 minus T2 by T1. 1 minus T2 by T1. 1 minus T2 by T1. T2 lower temperature 10 plus 273 and T1 higher temperature 2000 plus 273. So which is approximately it is coming 1 minus it is approximately it is coming 0.15. So roughly it is approximately it is 85. It is coming 85. So from these options answer is option D. For this problem answer is option D. Let us go to the next problem. What is the compression ratio of Otto cycle? Otto cycle is given. What is the compression ratio? Otto cycle. Cylinder diameter 50 mm is given. But stroke clearance volume is given 21.3 centimeter cube. Clearance volume is given in centimeter cube. So 50 mm which is equal to 5 centimeters and stroke length is given 75 mm. 75 mm is given which is 7.5 centimeters. Yes, he is asking compression ratio. Compression ratio R is equal to V1 by V2 which is also equal to Vs by Vc plus 1. So Vs can be written as pi by 4 d square L. Vs can be written as pi by 4 d square L. Pi by 4 into diameter is 5 centimeters, 5 square into L is 7.5. So by calculating Vs approximately we are getting 140 something, 140 plus something we are getting. This is Vs. We can calculate Vs. And by substituting Vs 140 something by Vc is already given 21.3 plus 1. Approximately it is coming 7 plus something. So if you calculate this is going to be 7.9. This is 7.9. So for this problem answer is option D. Let us go to the next problem. What is the specific volume of steam? Specific volume of steam. Pressure is given, temperature is given, considering it is perfect gas. Perfect gas, which is also called ideal gas. For perfect gas, PV is equal to RT. Specific volume we need to calculate. Pressure is already directly given, 17672 into V, which is equal to, R is already given, R is 0.4615 into temperature already given in the Kelvin. Temperature is already given in Kelvin, 647.3. So from this equation, we can calculate V. So if you calculate V, it is approximately, it is coming 0.018, it is approximately. So from this calculation, 0.018, it is option A. For this problem, answer is option A. And next question, which type of gas power cycle, which type of gas power cycle has limitation of isochoric heat addition and heat rejection? Isochoric heat addition and heat rejection means isochoric heat addition and isochoric heat rejection, which means constant volume heat addition and constant volume heat rejection also. Limitation means not valid. It is not valid. It has limitation means it is not valid. For which of the following cycles this is not valid, he is asking. And he has said piston cylinder arrangement. He has given one clue, piston cylinder arrangement. So first option, if you take Carnot cycle is a theoretical cycle. For Carnot cycle, the arrangement can be piston cylinder arrangement or it can be a open system like turbine. So it is not a Carnot cycle. Next, let us go to the Otto cycle. In Otto cycle, heat addition itself constant volume and heat rejection also constant volume. So for Otto cycle, there will not be any limitation because for Otto cycle, heat supply, heat rejection both are constant volume. If you go to the diesel cycle, in diesel cycle, heat is supplied at constant pressure. Here, there is no question of limitation here because heat addition itself constant pressure. There is no limitation. But if you take dual cycle, in dual cycle, during heat supply, partially it is constant volume and partially it is constant pressure. So totally it cannot be constant volume. In dual cycle, some of the heat is added at constant volume and remaining part of heat is added at constant pressure. So here there is a limitation. Total heat supply cannot be constant volume because of this limitation. Answer is, for this problem, answer is, so it is not Carnot cycle, it is not Otto cycle. In the diesel cycle, there is no question of constant pressure. So for this problem, answer is option D. In dual cycle, there is a limitation because it has to satisfy both. This is constant volume and this is constant pressure. Because of this constant pressure, there is a limitation. Therefore, answer for this problem is option D. So this is for thermal. Next, my friend is going to take next topic.
Hello guys, myself Hazrat. Now we'll see the questions from Strength of Material Engineering Mechanics. From SYM total 11 questions came and from EM total 6 questions came guys. It's a pretty much same pattern they are following since past 5-6 years. Now coming to the first question, what is the section modulus for a triangular section of base width and height H is given? See, if I take a triangular section guys, you know I value. I equal to how much guys? BH cube by 36 and this is the Y max value guys. This is equal to how much? 2H by 3. Then what is section modulus formula? Z equal to I by Y max, which means that BH by 36 by 2H by 3, it is coming as BH square by 24. The answer is option B.
Now, coming to second question, guys. What is the maximum bending moment for a simply supported beam as shown in the figure? Here, observe carefully. Whenever simply supported beam subjected to symmetrical loading, guys, where is the maximum bending moment? At the center. But here, as it is symmetric, I can directly find out support reaction is P by 2 here, P by 2 here. What is the maximum bend at the center, guys? P by 2 into L by 2. How much, sir? PL by 4. Just by seeing, I can able to answer this question, guys. Next, coming to next question, guys. What is the maximum shear force for the simply supported beam loaded by a couple T? Then what is the shear force is asking, guys? For this shear force, we need to find out support reaction. How can I find out support reaction, guys? If I know this is M, if you find out, guys, direct formula, guys, M by L, this should be downward, M by L. How is the shear force diagram? Upward M by L, constant M by L. So this is the positive value, guys. So maximum shear force is how much, my dear students? The answer is M by L. Here M equal T, guys. The answer is T by L. Option A. Next. Coming to next question, my dear students. A surveyor steel tape. Please go through the question. What the question they're asking is, there is a steel tape is there. He's applying a 120 newtons load. What is the elongation of that bar equal to how much? Pretty straightforward question, guys. Delta L equal to simple PL by AE. So, P equal to how much, my dear students? 120 newtons he is applying. 120. L equal to how much, sir? 30 meters. Just to confuse, they given unnecessary data. This 150 meters completely not required, guys. Into L equal to how much? 30 meters. Take care of the units, guys. Into 10 cube mm. By area. Area equal to how much, guys? 15 into 0.75 into E. E equal to how much is given? 22 pascals, guys. 200 into 10 cube. Now, what you do is exactly, if you just simplify this one, we're going to get approximately 1.6 mm, my dear students. Now, coming to next question. Which one of the following is defined as the ratio of shear stress to shear strain? So, pretty straightforward. Answer is shear modulus. Shear modulus equal to ratio of shear stress to shear strain. Next, the extension of a bar uniformly tapering. Listen, this is a little tricky question, guys. There is a bar is there. Cylindrical bar. This side how much, my dear students? D plus A. This side D minus A. And there is a load P is applied. Because of the load P, observe carefully, you will get the deformation. How much is the deformation? Assume delta L1. What the formula, guys? PL by pi by 4 into D plus A into D minus A, which means that I'm going to get D square minus A square into E. This is the original deformation, guys. Then what he's asking is, but how he has calculated? By treating the bar as a uniform cross section having a diameter D. This supposed to be original deformation, but he has calculated by assuming uniform diameter. If it is a uniform diameter, my dear students, what the deformation is coming as? Delta L2 equal to PL by pi by 4 D square into E. Then is asking what is the percentage error? What is the percentage error? How much error we should get? This is the actual, this is what he has calculated. What is the percentage error? So percentage error equal to how much, guys? Delta L1 minus delta L2 by delta L1 into 100%, guys, exactly. If you just substitute this PL pi by 4, everything will be cancelled each other. You will get the answer 100 A square by D square, guys. Okay, answer is option D itself. Now coming to 67. What is the torque if a shaft of 200 mm diameter can transmit safely? The shear stress should not exceed 50 megapascal. The question is asking, guys, what is the maximum torque I can able to apply to the shaft so that stress should not go beyond 50 megapascal? What is the formula, guys? Pretty straightforward. Tau max equal to 16T by pi D cube. That equal to how much, guys? 50 megapascal. Unknown is what? T. D is given as 200 mm. Just substitute, my dear students. You get the answer. T equal to 50 into pi d cube by 16, you get the answer. Be careful about while you are calculating, guys. 78.54 kilonewton meter, guys. Next, for the design of a thin cylindrical shell, please take care of it. Thin cylindrical shell, if Fa is the allowable tensile stress, this Fa is the allowable tensile stress for the material of the shell, then thickness T here is given, diameter given, and internal pressure is given. Now, what is the criteria for the thickness? Ultimately, I need to design a thickness of the thin cylindrical vessel. How can I do it, guys, exactly? In case of thin cylinder, maximum stress is what, my dear students? Hoop stress. What that formula? Sigma max equal to PD by 2T is given. This stress should not exceed Fa. But I want T. How can I find out, guys, exactly? PD by 2 Fa must be less than or equal to T, which means that T is greater than PD by 2 Fa, means the answer is option D, guys. Now, coming to 69, consider the following assumptions for Lamb's problem of stress distribution in thick cells, which means that in thin pressure vessels, what are the basic assumptions we have to follow? First, the material of the shell is heterogeneous and isotropic. Absolutely wrong. Why? Because, guys, always we assume metal is homogeneous and isotropic. If you can avoid one, these two will be struck off. Next, plane sections of the cylinder perpendicular to the longitudinal axis and remains plane under the pressure, which means that the cross section should not get distorted. Are you getting an answer? Which means the plane cross section remains plane. This should be the perfect assumption we have to assume. So 2 is correct. Third one is material is homogeneous and isotropic. Yes, this is also correct, guys, exactly. The answer is 2 and 3. Option C is the correct answer. Now, coming to next one, my dear students. Statement 1. When a material is subjected to tensile strain, there is a simultaneous shortening of dimensions in the perpendicular directions, which means that if I try to elongate in one direction, other direction will be contracted. Yes, this is absolutely correct. Next, statement 2. The ratio of the shortening of the strain to the tensile strain is called Poisson's ratio. Yes. This ratio is called Poisson's ratio, and why this is shortening, guys? Because of Poisson's ratio, it is shortening, guys. That effect is called Poisson's effect, we used to call. So, statement 1 is correct, statement 2 is correct. 2 is the correct explanation of statement 1. The answer is option A. Now, coming to next one, guys. Toughness is the ability of a material to absorb applied energy without failure. Yes, absolutely correct. And second statement, this absorbed energy is called exactly, sir, impact energy, impact resistance. Yes, this statement is correct, this statement is correct. Both are two independent statements, my dear students. There is no logic between these two. So I can say the answer is both statements are correct and 2 is not correct explanation, my dear students. Next, now we'll see the questions from engineering mechanics, guys. First question. In a static load analysis, the difference between dynamic load and static situation is, please tell me, guys, what is the difference between static condition, dynamic condition, guys? Presence of acceleration. If the acceleration is present, it is called dynamic. If the acceleration is absent, it is called static. So the answer is option A, guys. Next, in the frame as shown in the figure, an external force P is applied here. Which of the equations correctly represent the laws of sine law or cosine, the sine rule, my dear students? Very simple. P by opposite angle, guys. Here, what is the angle, guys? Angle between these two forces. This is the P. How much, guys? F of AC, P of AC, P of AB. Please tell me, my dear students. This is 70, I thought. This should be 110. If this is 110, this should be 35. So, if you use the Lami's format or sine rule, my dear students, it should be what? P by sine 35. So P by sine 35, no need to do the remaining things, guys. P by sine 35 is present only in the option C. So option C is the correct answer, guys. Next, consider the following properties for a line loads distributed along a plane curve. Assume there is a plane curve. The loads are distributed like this. Assume for time's sake, guys. Then magnitude of the resultant force is equal to area under the loading diagram. Yes, absolutely. I want to find a total load. How can you find out, guys? Exactly. Area under this curve will give you definitely magnitude of the resultant force. Perfect. And second statement talks about where that one will be acting at the centroid of the area. So this one also correct, guys. Next. The line of action of the resultant force is always vertically upward. It is not necessary. It depends upon how the load it is, guys, exactly. So 3 is wrong. The answer is 1 and 2 is correct. Okay, next. A 50 kg block, assume there is a 50 kg block is there, and he has given coefficient of friction is given, guys, exactly. He's applying a force from 0 to 150. The question he's asking is, what is the maximum static friction force? He is not asking friction force at that point. He's asking what is the maximum static friction force, means limiting friction is asking, sir. So limiting friction formula, US Fs equal to how much, guys? US times of N. US is given as 0.5. N means what exactly? mg weight. 50 into 9.81, guys. Even if you take it 10, it is approximately get to 250, guys. 250 as it is less than 10, I'm going to get 245.25 newtons. Answer is option B, guys. Okay. Next. This is a little tricky question, guys. A bicycle and rider of mass 120 kg traveling at a speed of 115 kilometers per hour. Please go through the question. I will explain you what he's asking is. A person is riding a bicycle. He has suddenly applied a brake. But why the bicycle will stop, guys? Because of the friction force. But is it stops all of a sudden? No. It deaccelerates sometime and then stops. The question is asking is, what is the braking distance equal to how much? How far does the bicycle travels before it comes to rest? Are you getting an answer? How can you find out? Simple SWAT equations. What are SWAT equations are valid, guys? V square minus U square equal to how much, guys? 2AS. Are you getting an answer? Here, it is deaccelerating, means it should be minus 2AS, guys, exactly. Final velocity should be 0. Initial velocity how much, guys? Minus getting cancelled out each other. 15 kmph. 15 into 5 by 18 meter per second whole square, that equal to 2 into A into S. My task is to find out S. So to find out S, what is unknown, guys, here? A. How can you find out A, guys? For this, he has given this formula, guys. Friction force. Friction force equal to how much, guys? Mu times of N. Only friction force will try to oppose the body, guys, exactly. This friction force must be equal to MA. A equal to how much, guys? Mu times of N by M. UV equal to how much has given, guys? Please go through it. 0.05 something. 0.05. N equal to how much, guys? Mg. M is how much, guys? 120 into G by again M. If you strike off, guys, exactly, just substitute this A value here, you get the answer S equal to 208.33 meters. Answer is option C, guys. Next, coming to this one. When 3 concurrent forces are in equilibrium, then each force is inversely proportional. Please go through it, guys. Inversely proportional is absolutely wrong. Why? Because, guys, according to sine rule or Lami's theorem, P by sine alpha equal to Q by sine beta equal to R by sine gamma equal to constant. Which means that P equal to how much, guys? C into sine alpha means it is a proportional, guys. It is a proportional, not inversely proportional. So statement 1 is wrong. Next, statement 2. The algebraic sum of moments of all the forces about any point is equal to the moment of the resultant forces about that point. It is a typical Verigne's theorem, my dear students. The statement 2 is correct. So answer is statement 1 is wrong, statement 2 is correct, my dear students. I hope that's all from engineering mechanics and strength of material. I hope you have done well, my dear students. I wish you all the best, guys. Thank you so much.
Good morning, friends. The 76th question, it's on a spark ignition engine. The cubic capacity of a 4-stroke over square spark ignition engine is 245 cc. Over square ratio is 1.1. The clearance volume is 27.2 cc. What is the stroke length of the engine? So it's an over square engine. That means L by D ratio is equal to 1.1 or L is equal to 1.1 D. Total volume is equal to clearance volume plus stroke volume. And stroke volume is given by pi by 4 D square L. And L is equal to 1.1 D. Now suppose if you substitute all these things in this, you will be getting a function in diameter cube. The diameter cube is equal to, roughly on solving, is 251.86. The cube root of it is lying between 6 and 7. The cube root of 216 is 6. The cube root of 343 is 7. Whereas our value here is 251.86. Therefore, it is between 6 and 7. Among the answers between 6 and 7 is 6.36. Hence, the answer is C.
Right. So here I am going to discuss the questions related to ESE 2023 from this maintenance subject. Now, the question here it is, which one of the following is mainly a surface crack detection technique which may be applied to all non-porous materials, but only cracks open to surface can be detected. See, open to surface defects are detected only by using a liquid penetration testing method. It is a low cost method. Liquid penetration testing method is used. And next question, which one of the following NDT method can be used for detection of internal voids and also are measuring thickness of surface coating? Generally, to measure the surface coating and internal defects, we are using eddy current method. Ultrasonic method also used to measure the internal defects, but we are measuring the thickness of insulation or thickness of surface coating. Eddy current method we are using especially. So this is the C is the correct answer for this question. Now consider the following statements for vibration monitoring of wind turbines. Okay. See, vibration monitoring of wind turbines, position sensors are used for low frequencies and velocity sensors are used for medium range frequencies and accelerators are used for high frequencies. So all the correct statements. So D is the correct answer for this question. And the last question, the data set is said to be incomplete if it contains, like if it incomplete, right? If it not contain both failure and the sensor data, otherwise any one of the data. So C is the correct answer for this question. And next one, consider the following common failure mechanisms found in gas turbine blades. See, especially gas turbine blades are mainly failed by the creep failures, and also the gas turbine is working at a high temperature, so high temperature damage also we should consider. And also we can't say that only these two failures are present. There may be a mechanical damage also present, right? So here in the option D, all three are given. So most probable answer for this question is D. So D is the correct answer for this question. And next, I'm going to discuss about the renewable energy sources, the questions related to renewable energy sources. Now, the principal characteristic of an ash collector is the degree of collected, which will be given by the quantity of ash entered in ash collector per unit time, quantity of uncollected ash. So here quantity of ash collected, G1, the total one. So G1 minus G2 by G1 is the direct answer, so is the correct one. And pyranometer, there is another question, that is pyranometer. This pyranometer is used to measure the solar radiation. That includes direct and diffuse solar radiation. And this instrument cannot be used to measure the diffuse radiation by blocking out the direct radiation with a shadow blade. It is not correct. This instrument is also used to measure the shadow radiation. So only one is the correct answer for this question. And Another one is most of the reflection occurs from the clouds, which is a small proportion from the Earth's surface. That reflection is known as albedo. Clouds, from the clouds, reflection occurs from the clouds is nothing but albedo. Right. This is a formula based question, Hotel-Vellier-Bliss equation, expressed heat collected and per unit area. The term data is given directly, formula based question. So C is the correct answer for this question, formula based question directly. Right. And this is the very, very easy question. This question Q is equal to mCp into delta T. By using this, M is not given, but density is given, rho V into Cp into delta T. By using this, you'll get density of like water is 1 approximately. So 4.9 into 4.19 into 26 minus 18, 5 meter cube. 26 minus 18, how much? 26 minus 18, like 6 plus 8, like. Right, it is, you will get 8. So by solving this, you will get the answer, that is C, 167.67 approximately you will get the answer. And here the question, that is a formula based question. Here the formula based question, the waves are created by tidal energy equation. This tidal energy directly proportional to the square of height. Remember, tidal energy is proportional to h square. Tidal energy is proportional to h square. So B is the correct answer for this question. Right. And fuel cell converts chemical energy into electricity directly with no internal combustion engine, with no any other type of intermediate thing are there. So directly with no intermediate combustion cycle, directly we can use. So B is the correct answer for this question. And efficiency of conversion from chemical to electricity by fuel cell. Generally, fuel cell efficiency is more than 60% actually, practically. So here practically more than less than 50 is there, 75 is there. So practically more than 75%. So D is the correct answer for this question. So these are the questions related to renewable energy. Next, our colleague D. Srinath will take about the robotics.
So good evening. Now welcome to ACE online platform. So now we are going to discuss about the subject of mechatronics and robotics, right? So that is ESE 2023 Prelims Paper 2. The subject is mechatronics and robotics. So here as we see the question concern here. So the weightage they are given, the total number of questions are 12. That is 31 question to the 42. This paper solution is made from the set D, I can say, right? So as we move to the first question, that is 31 question, I can say. So the question says that which one of the following statement is correct related to the type of microcontroller is given, that is PIC16F84, right? So the option A says that it is a low cost 32-bit microcontroller, And this option B says that it has a built-in ADC and DAC or serial communication capability, right? Similarly, the option C is given, it supports this model, whatever we have, this microcontroller will be going to support 13 digital input and output lines and serves as a good learning platform. And option D says that it is a low cost and has a difficulty of programming, right? So among this one, we need to choose the correct statement, like I said, right? So here, if you see the basic, the features concerned to this type of microcontroller is that, so it has the 13 digital input and output lines and serves as a good learning platform, right? So hence the option C is the correct one. And remaining options are incorrect, I guess, right? So from the given the features here, right? So that is about the 31 question. So as we move to the next one, the question says that what is the smallest step size, that is a resolution, I can say, so of a 4-bit analog to digital converter which has a maximum output voltage of the 12 volts. So here, as we know that in order to find out the resolution, we have the basic formula, that is the full range of the scale by this, I can say the number of output states, right? So here from this, the maximum voltage is given, that is 12 volts, I can say, and the minimum voltage is 0 bits, right? So here from this equation, as we know that, so from this we can calculate the resolution of the resolution, I can say, right? So that is a 0.8 volts. So from this, we can say that the option B is the correct one. So here, as we move to the further, that is the 33 question, question number 33, I can say, which one of the following effects states that if the wave source or corresponding receiver are moving related to each other, the frequency observed by the receiver will be greater than or smaller than the actual source of a frequency, I can say, right? The options are given, option A as a Doppler effect, and option B as a piezoelectric effect, and option C is a signal conditioning effect, I can say. And option D is that the variable capacitance effect, right? So here, based on this, the effect, I can say, so the correct answer is that option A, that is a Doppler effect, so which is also known as Doppler frequency shift, right? So as we move to this further, that is a 34 question, I can say, a DC motor equipped with incremental optical encoder is used to drive a lead screw, a positional table as given, that is along with the figure, I can say. So here we have an encoder, along with that we have the lead screw, I can say, and we have the motor, right? So from the given data, we need to find out the measurement of resolution, right? So we need to find out the resolution, I can say, right? So here from the given based on data, we can say, if we calculate the same thing here, so we are going to get the answer is 0.635 micrometers, right? So that is the resolution of the encoder, I can say, right? So hence the option answer is a D, I can say, right? So as we move to the further, that is a 35 question, the hysteresis of the schematic trigger in a typical circuit of for a all effect digital proximity switch is used to increase the sensitivity of the sensor to noise and false triggering, I can say. And option B says that make constant sensitivity of the sensor to noise and false triggering. The option C says that to reduce the sensitivity of the sensor to noise and false triggering, right? And we have the option D is that increase the sensitivity of the sensor to noise and true triggering, right? So here the option C is the correct one, I can say, right? So based on this, the Hall effect digital proximity switch, right? So the correct answer is that C, I can say, right? That is reduce the sensitivity of the sensor to noise and the false triggering, right? So the same solution has been given here, right? So as we move to the 36 question number, so in a stepper motor, which one of the following features eliminates the need for the brushes and the commutator, right? So as we see here, the stepper motor features we have, basically the 4 features we have. So among these here, the first one feature we have here, and the second one we have the another feature also, and similarly the third feature we have. So basically this question is related to the third feature of the stepper motor, I can say that. So that the third feature, which is that there are no wires connected to the rotor, which eliminates the need for the brushes and the commutator, right? So and we have similarly the fourth feature we have of the stepper motor. So from the given options, the answer B is a correct one, I can say, right? So regarding the detailed solution, we are going to discuss in upcoming sessions, right? So here, as we move to the further, that is a 37 question. Which of the following type of transducers are also known as the external powered transducers, right? So as we know that basically here the transducers are classified into the two categories, I can say. So here basically we have the two types. Here namely the passive transducers as well as the active transducers, right? So among this one, the passive transducers, which are also known as the external powered transducers, right? So from this, the correct answer is, I can say that the external powered transducer, which are also known as the passive transducer, right? So the same thing has been given in the solutions. Hence, the correct answer is for this one is that Bombay. B for right Bombay, right? So as we move to the further, that we have the question related to the 38 question number is a concern to the robotics, I can say, right? So here they are given the two statements. So among that, we need to find out the correct statements, I can say, right? So either one only correct, or the option B says that two only correct, or option C says that both 1 and 2 are correct, and option D says that neither 1 nor 2, right? So here if you see the statement 1, that is a multi robot system whose dynamics are written is observable if and only if it is controllable, right? And similarly, the duality principle can be invoked to show that the multi robot system is controllable if and if it is observable, right? So from these the basic concepts of the multi robot system, we can say that both given statements are, the statement 1 and statement 2 both are correct, hence the option C is the correct one, right? The same solution has been given here. So further, as we move to the next question is that, so here the question number we have, there is a 39 question number, I can say, which is again concerned to the type of robot systems are given. So which one of the following are used in a material handling systems for moving the raw material or a partly finished goods from one workspace to the another within the manufacturing facilities, right? So as we see, the options are given. The option A is that stationary robots, and the option B says that the mobile robots, right? So and the option C, we have automated guided vehicles, and the option D is that robotic arms, right? So basically here the robots are classified into the two categories. One is the mobility of mobile robots as well as the stationary robots, right? So under this mobile robots, we are going to come across the automated guided vehicles, which will be going to consisting of a wheel type of things, I can say, which are the automated guided vehicles are typically wheeled robots, I can say, right? So which are basically used for the same application, right? So that is the option C is the correct one. So as we move to this further, that is the next question, I can say that is the 40 question. So which is again concerned to the statement type of question, I can say, right? So here they are given the question related to the Jacobian concept, I can say, right? So here the first statement is given that at a velocity level, the manipulator Jacobian relates to the joint velocities to the end effector of velocities, right? And similarly, the second statement is given that the manipulator Jacobian is important in motion planning as well as for identifying the singularities, right? So the options are given. So among that, we need to find out the correct one, I can say, right? So here from the basic concept of the Jacobian matrix, or which is related to the robotics, I can say. So both given statements are correct, right? So that is nothing but the answer C is correct, right? So answer C is correct. So the same solution we can see here. The solution has been given for respective Jacobian concept related to robotics, right? So as we move to the further, we have the 41 question, I can say. So which is a combination of the strength of material as well as the robotics, right? So it is basically, the question belongs to the design of robots, I can say, robot arm, right? So here the various data is given, that is already in front of you in a slide or in question paper, I can say. So from this we need to find out the deflection of the robotic arm, I can say, right? So here the options are given, the various options, and this question has to be calculated by the calculator. It is difficult to calculate with the hand calculation, I can say, right? So here it's option B, right? So here as we move to the solution part, so this question can be done with the help of the fundamental concept of a SOM as well as the robotics part, right? So here if in order to calculate the first one, the first step is given that the moment of inertia. From this we need to calculate the same thing. and after that we are going to find out the deflection of the robot arm, right? So from this we are going to get the 170 micrometer seconds, right? So here the same thing is given. There is option A is the correct one, right? So the respective solution is given here. So further, as we move to the next last question, I can say. So again, this question is concerned to the statement question. They're saying that consider the following statements. The robots are normally controlled using the microcomputers as well as the microcontroller, right? So the second statement says that the output from the robots needs to be transferred into usable form using the actuators, right? So here the options are given A, B and C and D, right? So here we need to find out the correct statements, right? So both given statements are correct concerned to this question, right? So hence the option C is the correct one. So this is about the mechatronics and robotics questions, and I would like to say all the best to our students.
So dear student, coming to IM and OR subject, only there are 4 questions. So if you see ESE 2016 onwards, almost all papers you can find only less number of questions in production side. Of course, those who are preparing for ESE 2024, so I can advise you, just you can see the previous question papers and based upon that you can have a plan. So from production side, definitely you may be finding only less number of questions, because not only this paper, even last 3-4 years papers if you observe, then you can find the same trend. Of course in IM and OR there are only 4 questions, and just let us have the solutions. The first question here, which one of the following is related to the process data such as production rate, efficiency, resource consumption? So this entire data is related to whether technical data, operational, maintenance and servicing data, or cost data. Then we can say it is operational data. So answer is option B. Next, which one of the following is excess available time over the activity time when all the jobs start as early as possible? So excess available time is nothing but float. Excess available time is nothing but float. Whether it is total float, free float, independent float, how do we decide? Depending upon some keywords, without affecting project completion time, or without affecting next activity, without affecting next and preceding activities. So these are the keywords. And this question, earliest value as mentioned. Early means, now just let us have the explanation regarding this. It's a matter of only a simple equation. Total float is equal to, as we know that, Lj minus Ei minus Dij. Available time minus required time. Coming to free float is equal to total float minus slack at head event, that is slack at J. Then if you substitute this Lj minus Ei minus Dij, slack value at J latest value minus earliest value. So LJ terms cancel. So what will happen? EJ minus EI minus DIJ. So free float is equal to EJ minus EI minus DIJ. So it is only related with the earliest values. So all jobs or all activities will start at earliest, means answer is free float. Option A is the right answer. So coming to next question, inventory related question. Which one of the following inventories are stocked in the manufacturing plant as a precaution in case of semi-finished from one machine does not come to the next machine and the stock is used to continue production? So when we have machine breakdowns and when you have any problem with the internal operations, so there is a need of some buffer stock that we can call as a work in progress or maybe work in process as well as in the form of semi-finished goods. So that is generally for the sake of coupling, like when you have some discontinuity that is really dangerous to the industry. So that's why the more interesting, like directly from the options, you can say decoupling inventories. So when you are having any decoupling, no, then there is a mismatching, like a connectivity, the sequence is missing, no, then for having restoration, we have some inventory. That is simply, even from the option, directly from the word also, decoupling inventory. Decoupling inventory is basically meant for some semi-finished goods in order to have a smooth operations and a smooth production, that is particularly machine breakdown cases. The remaining no need to work out and no need to think also. Anticipation, of course, for future demand point of view, we have this anticipation. Fluctuation inventory, generally inventory is maintained for only demand fluctuations. But the most appropriate answer is decoupling inventories. And coming to the next question, this is related to FMS. I cannot say it is a purely from industrial management, it is generally a production side. So FMS environment, that too, there are two types of FMS, dedicated FMS and even a random order. Random order in the sense we may be finding some kind of like a different products, like what we can say product variety is more. Flexible itself meant for product variety, and more production volume is generally the important feature. So as per these statements concerned, the first statement, if you see, the part family is very small. It is absolutely wrong. The part family need not be a small. So we can find different part families. There are, because FMS, the main feature is medium volumes and medium product varieties are different product varieties. The first one is wrong. The first one, if you eliminate, now obviously what is the answer? A is eliminated, B is eliminated, D is eliminated. Only answer is C. So that is, there are substantial variations in part configurations, and the next one, the production schedule is subject to change from day to day. Like any variation also, we can just entertain and we can permit. Okay, so that's all about IM and OR. The next thermal, like Malakunda sir is going to continue.
Hello dear students, I am Malakondaya, Thermal faculty in ESE Engineering Academy. Now I am going to discuss the solutions for today's ESE exam for mechanical paper, both R&AC and power plant engineering. Dear friends, in today's exam, only 4 questions asked from refrigeration and air conditioning. Only 4 questions. But this time, more weightage has given for the power plant engineering. Nearly 23 questions asked from power plant engineering. That too, more than 50% of today's questions from power plant engineering are very difficult. Right? You cannot get the answer without calculator nearly for more than 10 questions. Okay? Now look at the first refrigeration part. Look at the very first question. The first question is asked like this. Directions for the following, different statement given for the atmospheric air, room temperature 30 degrees centigrade. 1 minute. This is the first question. Yes, please. Please look at the first question. A refrigerator operating on reversed Carnot cycle extract 500 kilojoules per minute. Means refrigeration effect given 500 kilojoules per minute. Okay. From a refrigerated space being maintained, refrigerated space temperature is given TL minus 16 plus 273 to get in Kelvin. And it is rejecting, the refrigerator is rejecting the heat to the atmosphere at a temperature, I can say highest absolute temperature of the atmosphere, that is 27 degrees centigrade, 27 plus 273. Then what is the network required to run the refrigerator? Very simple question. As you know, the COP, it is clearly given reversed Carnot cycle. COP of reversed Carnot cycle equal to lowest absolute temperature by highest absolute temperature minus lowest absolute temperature. That is equal to, that COP equal to refrigeration effect by work input to the refrigerator. From this you can get the work input to the compressor, because the TL, TH and refrigeration effect given, I got the work input to the compressor around 83.6 kilojoules per minute. That is the answer. Look at the option D. Option D is absolutely correct. Okay? Similarly, look at the next question. Try to read this question. This question connected to the psychrometry. For the atmospheric air at a room temperature of 30 degrees centigrade, room temperature means I can say the dry bulb temperature 30 degrees centigrade, relative humidity 60%, RH value given 0.6, saturation pressure corresponding to 30 degrees centigrade, the saturation pressure corresponding to 30 degrees centigrade 0.0425 bar. That is the saturation pressure. What is the partial pressure of air? You are asked to find the partial pressure of the air. Means partial pressure of the dry air is how much? Right? You know, the atmospheric air is the mixture of dry air and water vapor. The barometric pressure, the total atmospheric pressure is equal to, the total atmospheric pressure equal to the partial pressure of the dry air plus partial pressure of the water vapor. Okay? Now, you need to find the, for finding the partial pressure of the dry air, from this partial pressure of the dry air equal to barometric pressure minus partial pressure of the water vapor. Okay? This partial pressure of the water vapor you can find from the RH value. The RH value equal to partial pressure of the water vapor dividing by the saturation pressure. The saturation pressure given, relative humidity given, from this get the value of partial pressure of the water vapor, and you put this value here for getting the partial pressure of dry air, and make sure that the PB, barometric pressure, is 1.01325, but that is standard value, minus partial pressure of the water vapor is giving the answer. My answer is 0.987 bar. That is the answer. Okay? Look at the option D. Option D is absolutely correct. Look at the next question. It is asked like this. For the atmospheric air at a room temperature of 30 degrees centigrade, relative humidity, this one given, the saturation pressure, the specific humidity or humidity ratio. You are asked to find the humidity ratio. Humidity ratio equal to what? 0.622 into PV by barometric pressure minus partial pressure of water vapor. Already you got the PV, barometric pressure is standard value, right? Simplify it for getting the answer 0.01606. That is the answer, 0.01606. Look at the option B. Option B is absolutely correct. Okay, na? Similarly, look at the next question. Look at the next question. The thermal comfort depends on environmental and physiological factors. Which one of the following is representing the physiological factor? Air temperature. No, air temperature is not physiological factor. Relative humidity also not physiological factor. Radiation not physiological factor. Amount of clothing, yes. The amount of insulation what you are wearing, right, in the air conditioning is the physiological factor. Option D is correct. So with this, my dear friends, I am concluding the refrigeration part. That means refrigeration and air conditioning problems completed. Now look at the power plant engineering. Look at the very first question, right? Very first question. Try to read it clear. The following data refers to an axial flow compressor. It is given for axial flow compressor, right? So much data is given. That entire data is not given. Here entire data is not required. Here speed is required and diameter is required, because for this question it is asking what is the mean blade speed. You know mean blade speed, U equal to simply pi dn by 60. That's all. The entire data, remaining data is coming under extra data. It is equal to pi d. D is how much? D is 140 mm. So D is 140 mm means you take in meters 0.14 meters. Speed is given. How much speed? 36,000. You put here for getting the mean blade speed. I got the answer around 263.76 meter per second. That is the answer, 263. Look at the option B. Option B is correct. Okay. Similarly, look at the next question. Right? It is asked like this. In an impulse steam turbine, steam is accelerated through a nozzle from the rest. Okay, means initial velocity 0. It enters the nozzle at a pressure given and saturated the height of the blade 10 centimeters and the nozzle angle given. Nozzle angle means alpha. Nozzle angle alpha is given. Nozzle angle alpha given. How much it is given? Nozzle angle is 15 degrees. 15 degrees. Blade velocity is, blade velocity generally denoted with U, equal to 144 meter per second. The blade velocity ratio, that means blade speed ratio, rho equal to U by V1. It is given 0.48. And the blade velocity coefficient, let it be CV, 0.97, right? What is the isentropic heat drop, right? You know, the velocity of the jet V1 equal to, this is the velocity coefficient, that V1 equal to, V1 equal to 44.72 into root under isentropic enthalpy drop multiplied by nozzle efficiency. Here the nozzle efficiency is equal to square of the coefficient of velocity. The coefficient of velocity is given. Okay, na? So from this, right, you need to find the isentropic enthalpy drop. For that I need to decide the V1 value. Right, that V1 value how can you find? From the blade speed ratio. Blade speed ratio, this 0.48, blade speed ratio rho equal to 0.48 is equal to U by V1. U by V1. U is how much? 140. U 144 dividing by V1. From this first decide the V1 value. You put this V1 value here for getting the isentropic enthalpy drop. Right, this isentropic enthalpy drop, I got around 47, right? So option C is correct. Approximately 48 kilojoules per kg. That is the isentropic enthalpy drop, right? Similarly, look at the next question. It is asked like this. So in a condenser set test, the following observations were made. Vacuum, right, is given 720 mm, barometer pressure given 765 mm, mean temperature of condensation given, hot well temperature, inlet temperature of cooling water, outlet temperature of cooling water, absolute pressure of steam corresponding to, that means saturation pressure, the saturation pressure of the steam corresponding to 34 degrees centigrade given 0.0533 bar. So, right, so the 760 mm of H is given as 1.013 bar. What is the vacuum corrected to standard barometer? Different options are given. You know, here it is given the barometer pressure is 765, vacuum pressure is 720. Then what is the condenser pressure? The condenser pressure equal to the barometer 765 minus 720, it is equal to 45 mm of Hg. But what he is asking what is the vacuum corrected to standard barometer. Here standard barometer pressure is 760. Then the vacuum corrected is equal to 760 minus this condenser pressure 45, that is equal to 715 mm of Hg. 7 mm of Hg. That is the answer. Look at the option C. Option C is absolutely correct. Okay. Similarly, look at the next question. It is now for the same data. What is the undercooling efficiency? Here undercooling efficiency means in this condensation process, right? The steam may be went for condensation. How can you know? The mean condensation temperature is given 34 degrees centigrade. Hot well temperature 9 degrees centigrade. That means condensate is entering to the hot well with a temperature less than the saturation temperature corresponding to condensation pressure. Right? Then what is undercooling? Undercooling equal 34 minus 29. Undercooling equal 34 minus 29. Then the undercooling efficiency is nothing but the condenser efficiency. The condenser efficiency equal to what? Actual temperature rise. Let me write it clearly. The actual temperature rise, the condensation efficiency is nothing but the undercooling efficiency, actual temperature rise dividing by maximum possible temperature rise. Here actual temperature rise of water is right, initial temperature 15, the final temperature of water is 25 minus 15 dividing by the maximum possible temperature rise. You know, corresponding to that 45 mm, you need to decide the the saturation pressure. Corresponding to 45 mm, the saturation pressure, right? Saturation pressure which is in bar is 0.06 bar. How do you get this value? This saturation pressure is equal to 1.01 dividing by 760 multiplied by 45. That is the condenser pressure, right, corresponding to that 45 mm. From this you can get this value. Corresponding to this temperature, the saturation temperature is right 38 degrees centigrade. So this value I have taken from the steam tables. That means this problem needs steam tables. Without steam tables you cannot do it. So this is the problem with insufficient data. Then the maximum possible temperature is this 38 minus 15. From this, right, you simplify that value. For getting the value is around 43.8%. That is how you can decide the undercooling efficiency is also called condenser efficiency. Similarly, look at the next question. The next question is what? For the same data, what is the undercooling of condenser? Undercooling of condenser is nothing but difference between 34 degrees centigrade, 29, 34 minus 29 is 5 degrees centigrade. Okay, option D is absolutely correct. Okay, similarly, look at the next question, right? For the same question, right, 4 questions, right? 4 questions are asking from the condenser part, right? What is the condenser pressure, right? Condenser pressure already we have decided 0.06 bar, right? I explained to you how to get the condenser pressure. That condenser pressure is equal to 1.013 dividing by, right, 760, right, dividing by 760 multiplied by 40, because 45 mm is the mm of Hg is the condenser pressure, right? This is equal to 0.06 bar. Okay, right? Next, look at the next question. It is asking like this: during a trial, single acting, single stage compression. Okay, the data given. Finally, let us see what he is asking. What is the volumetric efficiency? Right? Volumetric efficiency in terms of free air delivery. What is the volumetric efficiency in terms of free air delivery? Free air delivery dividing by the swept volume. Free air delivery is given 15 meter cube per minute. Here FAD, free air delivery, is given 15 meter cube per hour. then swept volume decide in meter cube per hour, that is equal to pi by 4 into d square into, right, stroke length into n multiplied by 60, because the n is given, look at the n value is given RPM, revolutions per minute, 1 hour equal to 60 minutes. Since free air delivery is there in meter cube per hour, you decide the swept volume also in meter cube per hour. For that you need to take the diameter, diameter is 10 centimeters and the stroke length 8 centimeters, but you take diameter and stroke length in meters for getting the swept volume. After you get the swept volume, you put here for getting the volumetric efficiency, right, I got around 79.61%, 79.61. Option D is absolutely correct. Okay. Similarly, look at the next question. It is asking like this, right? This is the problem connected to jet propulsion, right? For this data, for this question, data is given for the next connected question. I will explain to you. It is asked like this: a jet aeroplane flies at a speed of, jet speed given. A jet aeroplane flies at a speed of, flight speed is given 900. 1 minute. Flight speed is given. Flight speed is 900 kilometer per hour. For getting it into meter per second, multiply with 5 by 18. For getting the flight velocity is around 250 meter per second. Okay. Next, density of the air is given. Density of the air is given 0.15 kg per meter cube. And drag force means here thrust force. The thrust force equal to 6800 kilowatts. Okay. Next, consider jet plane has two jets. Jet plane have two jets and engine working on turboprop having the propulsion efficiency 56%. Propulsion efficiency given. Propulsion efficiency 0.56. Right. So, right, what is the absolute velocity of the jet? You are asked to absolute velocity of the jet. So, the jet velocity Vj equal how much? Jet velocity Vj equal how much? This propulsion efficiency equal to what? 2Va by Va plus Vj. From this you decide the jet velocity. Here actually I am getting the jet velocity is equal to 642.8 meter per second. This is the jet velocity. But no option is available. That means he might be asking the question, the relative velocity between the jet and the flight. Relative velocity between the jet and flight, 642 minus 250, I got around 392. The relative velocity is 392.86 meter per second. That is the relative velocity, not jet velocity, right? So anyhow, this is the now question, right, there is a ambiguity. So that is the relative velocity. Look, similarly, the connected question is asked like this. What is the volume flow rate? That volume flow rate generally you can find like this. The thrust force equal to mass flow rate of the air into Vj minus Va into Va. But thrust force is given in kilo, thrust to power, that is the thrust power, 1 minute. That is the thrust power, right? So thrust power is given in kilowatts, that's why dividing with the 1000, right? You simplify this, right, by putting mass flow rate of the air equal density of the air into volume flow rate. So volume flow rate. So thrust power equal to density of the air into volume flow rate into Vj minus Va into Va, dividing by the 1000, because thrust power is in kilowatts. From this you decide the volume flow rate. That is how you need to solve this problem, but option is not tallying, right? That is how you need to follow this problem. But right, so I got some other value other than these values. This is how you need to decide. Similarly, look at the next question. It is asked like this, right? 109. A single stage impulse turbine has equal blade angles. Equal blade angles means blade inlet angle equal to blade outlet angle. Next, and nozzle angle is 30 degrees. Nozzle angle alpha equal to 30 degrees. What is the maximum possible blade efficiency if the blade velocity coefficient given? Blade velocity coefficient generally denoted with 0.85. With blade velocity coefficient, the maximum blade efficiency is equal to 2 into rho cos alpha minus rho square into 1 plus Kc. This is the formula. The Kc, 1 minute. Kc, let me write it clearly. That is the Kc, K into C. Okay, K into C. Here C equal to cos phi by cos theta. This C equal to 1. Why it is 1? Phi and theta both are equal. Okay, K is given and alpha is given. This rho value, rho means here it is not density. Rho equal to blade speed ratio equal to U by V1. Blade speed ratio, right, is U by V1. That is equal to, it is given for simple impulse turbine. For a simple impulse turbine, optimum blade speed ratio equal to cos alpha by 2. Cos alpha by 2. It is equal to cos alpha. Alpha is how much? 30. Cos 30 divided by 2. Some value you are getting, all values are known. Put there for getting the value around 69.4. That is the answer. Look at the option D. Option D is absolutely correct. Okay. Similarly, have the next question. Consider the following statements. Impulse turbine stage has pressure drop occurring in moving blades. No, impulse turbines are constructed to have the same pressure. Right? Reaction turbine stage has pressure drop occurring in both fixed as well as moving. Absolutely correct. The reaction turbine blades are constructed for having the drop of pressure continuously in both fixed blade and moving blade. Reaction turbines have complete admission of steam or steam being admitted all around the rotor. Yes, absolutely correct. 2 and 3. Look at the option B. Option B is absolutely correct. Okay. Similarly, look at the next question. Look at the next question. What is the type of steam turbine is also known as Curtis turbine? Curtis turbine means velocity compounding steam turbine. Pressure compounding steam turbine, reactive turbine. The velocity compounding steam turbine is called Curtis turbine. Okay. Next question. Look at the next question. A reaction turbine has a mean blade speed of 180 meter per second. Blade speed velocity ratio. Blade speed U equal to 180 meter per second. Blade speed ratio, that is U by V1, I can mark as rho equal to 0.8. Outlet angles of fixed and movable blades as 30 degrees. Outlet fixed blades angle means alpha. Alpha equal to, of course, for a reaction turbine, since reaction turbine is a 50-50 turbine, alpha equal to 5, I can say 30 degrees. And the theta equal to beta. Theta equal to beta may be equal to 35 degrees. 35 degrees, fixed and movable blades, right? Specific volume of the fixed blades given under the blade outlet, okay, some values are given, K square given, where K, some value given. What is the axial velocity component? Data is not required. Axial velocity at the inlet. Axial velocity at inlet, VA1 equal to simply V1 cos alpha, that's all. V1 by, right? So V1 cos alpha, right? First you decide the V1 value from this. From this V1 equal to what? Blade speed by 0.8, right? V1 is known, alpha is known, yes, you put here axial velocity. Very simple question, right? So the axial velocity I got around 112.5 meter per second. Option D is correct. The remaining entire data is coming under extra data or superfluous data. Look at the next question. Look at the next question. It is asked like this, right? In a surface condenser operating with steam turbine, the vacuum near inlet, right? The vacuum near inlet of air pump is 69 cm of Hg. When barometer reading is 76 cm of Hg. Temperature at the inlet of the vacuum pump is 30 degrees centigrade. Air leaking occurs at the rate of 60 kg per hour. Take 1 centimeter equal to 133.32 Pascal. What is the absolute pressure at the inlet? Simple, very absolute pressure at inlet. Absolute pressure at inlet. At inlet simply equal to the 76 minus 69. What is the value? 9. It is 7 cm of Hg. 7 cm of Hg. But options are given in kilopascal. Options are given in kilopascal. But it is given 1 cm equal to 1.33322 kilopascal. Okay. So 1 mango equal to this much. Then 7 mangoes is how much? So it is equal to 7 multiplied by 1.333. You simplify this value for getting around 9.33. 9.33 kilopascal or kilonewton per meter square. 9.33, look at the D, D is absolutely correct. Okay, similarly, look at the next question, the same question, right? What is asking, what is the partial pressure of air if the saturation pressure at 30 degrees centigrade is taken as 4.246. What is the partial pressure? Here partial pressure equal to, what is the pressure, already we got it, partial pressure of the condenser is 9.33 minus the saturation pressure corresponding to 30 degrees centigrade, 4.246. Simplify this value, we are getting around 5.08 kilopascal. Okay, na? Option C is absolutely correct. Okay, similarly, next question, right? In a power plant, the efficiencies of the electric generator, turbine, boiler, cycle and overall all are given. What is the percentage of the total electricity generated is consumed in running the auxiliaries? You know, the overall efficiency equal to generator efficiency, turbine efficiency into boiler efficiency into the cycle efficiency into auxiliary components efficiency, right? So overall efficiency, all these factors are given. First find the auxiliary components efficiency. This auxiliary components efficiency is equal to net power divided by gross power. This net power equal to what? Gross power minus auxiliary components power dividing by the gross power. Okay, na? So from that what can I get? The auxiliary components efficiency equal to 1 minus auxiliary components power divided by gross power. From this you decide the auxiliary components power by the gross power, that is nothing but 1 minus, right? So this part is equal to 1 minus auxiliary components efficiency. That is, he is asking, I got around 7.4%, right? So that auxiliary components efficiency or the auxiliary components power dividing by gross power is equal to 1 minus auxiliary components efficiency. So this value I got around 7.4%. Look at the D is correct. Okay. Similarly, look at the next question. It is for the forced draught system. A forced draught fan supplies air at a rate of 10 meter per second. Velocity of the air is given 10 meter per second. And draught in terms of mm of water. HW equal to 20 mm of water across the fuel bed. So the 2500 kg of coal means mass of the fuel given 2500. It is given in kg per hour. Okay. Next, and is consuming 60 kg of air is supplied per kg of the fuel burn. That means mass of the air dividing by mass of the fuel given 16. From this you decide the mass of the air. It is giving in kg per hour because mass of the fuel already given. Next, the temperature of the flue gas is given at the inlet and outlet. The density of the air is given, right? What is the total pressure head produced by the fan? Very simple. Total pressure produced by the fan is equal to pressure due to velocity, that is rho v square by 2. Since it is given in Newton per meter square, I need not to divide with 1000. Rho v square by 2 plus rho, this is the pressure due to velocity and pressure due to water column, that is 20 mm of water, rho of water into G into HW. This HW how much is given? HW given 20 mm, that is equal to 0.02 meter. It should be in meters. Density of the water I need not to give. This is 1000 kg per meter cube. You simplify that value for getting the total pressure developed by the fan, right? I got this value around 255, approximately 255, approximately Newton per meter square. Look at the option B is correct. Okay. Similarly, look at the next question. It is asked like this. What is asking finally? What is the volume flow rate of the air? For that, first we decide the mass of the air. mass flow rate of the air equal to what density of the air, mass flow rate of the air, 1 minute. Here mass flow rate of the air is equal to some 16 into mass flow rate of the fuel. Mass flow rate of the fuel given in kg per hour. So this value we are getting right in kg per hour. What is asking? What is the volume flow rate? Right? This now mass flow rate density equal to mass by volume flow rate. From this volume flow rate, from this you should be very careful while we are discussing in the limited space. Volume flow rate is equal to mass flow rate of the air dividing by density of the air. But mass flow rate is given, mass flow rate is in kg per hour, right? You make sure that mass flow rate of air is in kg per second. That means you divide that fellow by 3600 for getting the volume flow rate. I got the volume flow rate around 9.45. It is equal to 9.45, right, meter cube per second. You should be very careful with the units. Okay. Similarly, have the next question. Try to read it. So for the same question, right, 3 questions asked from forced draught system. What is the power required to run the forced draught? Forced draught fan is the open system. Open system is steady flow device, right? For a steady flow device, the steady flow work equal to what? The fan power equal to simply VdP. VdP. Already got volume flow rate, dP, right? dP, right? dP already got it. V, right? V I got 9.44, 1 minute. Yes, V 9.45, V 9.45, dP something 255 something you got it, right? 255 1 minute. Yes, 255. You simplify this value for getting the answer. So I got 2.44 kilowatts. Okay, na? Next. Look at the next question. So this is a very simple question. Actually, this is from basic thermodynamics. It is asked like this: in the cylinder of air motor, the compressed air has a specific internal energy, right? 420 kilojoules per kg at the inlet, U1 given, and at the end of the expansion, specific energy given, specific internal energy U2 given. After expansion, what is the heat transfer from the cylinder when the work done by the air during the expansion? Work is given by work done by the system during the expansion, 100 kilojoules. 100 kilojoules per kg. Okay, you are asked to find the heat transfer. For a closed system, heat transfer Q equal to work done plus U2 minus U1. That is the non-flow energy equation. From that you decide the heat transfer. I got the heat transfer, right, minus 120 kilojoules per kg. That is the answer. Look at the option A. Option A is absolutely correct. Okay. Similarly, it is for the, it is also actually from the basic thermodynamics. It is asked like this: in a turbine, the gas the gas turbine unit gases, right, mass flow rate of the air is given and power developed given 14,000 kilowatts. The specific enthalpies of the gas at inlet and outlet given, and velocities at inlet and outlet given. What is the rate at which the heat is transferred? The rate at which the heat is transferred is found by the steady flow energy equation. What is the steady flow energy equation? By ignoring the potential energy m dot into C1 square by 2 plus H1, right, plus Q is equal to m, that Q should be 1 minute. So m dot into H1 plus C1 square by 2, right, plus Q dot is equal to m dot into H2 plus C2 square by 2 plus W dot. The W dot and Q dot should be outside the mass flow rate. Make sure that enthalpies and kinetic energy both are with the same units. From this you can get the value, right, the heat transfer around 119. The heat rejection, it is asking heat rejection, right? The value I got is, from this you can get the heat transfer 119.35 kilowatts. That is the amount of heat rejected. Kilowatts. 119.3 kilowatts. Option D is absolutely correct. Okay. Similarly, so it is a question connected to the steam engines. Actually, in the current syllabus, in the present syllabus, steam engines are not included in the syllabus. That means it is out of the syllabus. Anyhow, let us read the question. Statement 1. Tandem type compounding of steam engines has the inline cylinders having pistons mounted on the same piston rod, which is further having crosshead and connecting rod providing power output at crankshaft. That is the statement 1. Statement 2, something is given. Look at the statement 3. Here statement 3 can decide the answer. Receiver compounded engine is also a cross compound engine having 2 cylinders without phase pistons and receiver. Receiver compounded engine must be maintaining the receiver, but it is given that right, it is having without receiver means this statement is absolutely correct. Now you decide the answer. Without having the 3, right? So D, B and 1, right? C all are having the right third statement. Third statement is absolutely wrong. Then by elimination method I can decide the option A is absolutely correct. Actually this is out of the syllabus question, right? But by looking at the third statement, straight away you can get the answer. Okay. So with this, my dear friends, all the questions, right, for the power plant engineering, I try to explain. Thank you. God bless you.
My dear friends, actually in IC engines, already Sir has taken the questions and he has solved the questions, but one small correction is there in question number 83, in question numbers 83, 84 and 78. In these 3 questions, actually, since Sir did not have calculated, because calculator is not available, So that's why again he has calculated and he has given the final answer values for question number 78. This is 78 question number. For 78 question number, the answer is going to be the percentage loss. The percentage loss, it is 19.42. So therefore, for this problem, answer is going to be option B. Option B is the correct answer. Actually, earlier calculations and now, because of the final calculation, there is a mismatch. For this problem, answer is option B. And for question number 83, one second please. For question number 83, one second. Yes. For question number 83, the mean effective pressure. The mean effective pressure is 8.33 into 10 power 5 newtons per meter square. This is the actual answer. So from the options, answer is going to be option D, 8.33 into 10 power 5 newtons per meter square. For this question, answer is option D actually. And for question number 84, the indicated power. For question number 84, the indicated power is going to be, for question number 84, the answer is going to be option A. It is 22.59 kilowatts. The answer is coming to be 22.59 kilowatts. Therefore, the answer is going to be option A. For this problem, answer is option A. So actually, sorry for the inconvenience caused due to the wrong calculations. So that's all for mechanical engineering ESE 23. Thank you for all.